Hello everyone, and welcome to this training titled Materials and Textures in Houdini. The primary purpose of this training is to look at the variety of materials and textures that are available inside of Houdini. The idea here is that anybody transitioning from another software, the central focus here would be 3ds Max, since I used to be a 3ds Max user. And if you are shifting to Houdini and you're starting to build materials and textures, and you're trying to look for similar functionality or similar maps inside of Houdini, so this training will primarily help you work out, where all those things are, and if certain functionality is not available, then how to build something like that in Houdini. So that will be the start point. And then we'll also take a look at how Houdini's procedural structure allows you to take it a lot further. And then eventually we will build a variety of procedural maps from scratch to see how far the entire material structure in Houdini can be pushed. So to start with this lesson, we'll just do a comparison between the material that is available in 3ds Max and the materials that are available inside of Houdini. So let's build a basic scene. So I'm just going to create a grid and we will give it a UV texture. So take a UV project. This is basically like the UV mapping modifier that you get in Max. So if you press enter, you should be able to see like a tiny little square, and that's your gizmo. The projection types are here, so you can do orthographic is planar, polar is spherical, cylindrical, and you have a torus as well. If I zoom in close, you should be able to see it there. And you have plastic wrap, so we had plastic wrap as well. So we'll just take orthographic, and then if you come to initialize, and then you can just hit initialize and it'll set it to the best plane. And you'll see that everything sort of, it sets up the whole thing here. So once you've done this much, then we'll just come up. I'll create an environment light. We'll use it later, but I'll just create a light anyways. We'll create a renderer. So we'll just create a basic mantra, and in properties, make sure it's on ray tracing. So we don't really want to change that. And then finally, we'll create a shop network. Now, when you come to material palette, it by default will go to a global folder. So if you look here in OBJ, and if we click there, then you have, like if you click here, see these are all the global folders. So if you don't create a custom manager or your own folder, then it's going to go there, which isn't a bad thing, but it's just a little, sometimes I find it a little difficult to find. So I prefer to create my own shop network. So anyway, so once you come to material and you've created it, then you'll find two folders. So first one is the basic shop folder, that is the global one, and then this is obj shopnet one, which I had created. So if I change it to something like, say, my materials, that's what it will be called. Now unlike Max, well, even in Max you get it. Like if you come into here, then V-Ray gives you like a ton of different materials, but these are all kind of actually different materials. With Houdini, the interesting thing is that you do get a lot of these, but they're essentially variations of the same thing. So think of these more as presets than actually separate materials, unless you come to something specific like you have these guys like Sprite and Dust Puff, and then you have these smoke shaders. So these are basically for volumetrics, but the basic ones on top, like these are essentially variations of the same thing. So if I take clay and I'll take a mantra surface, and then we have a surface model. So if you come into my materials, then you'll see it has created 3 nodes. To assign it is fairly simple. You can drag drop from here, that works. Or if you come to the object, then you can sort of pick it from there. So if you open this up, then you should be able to pick it from there. Now the interesting thing here is mantra surface is the primary one that you want to use in about 90% of the cases. So this is something that you can compare to the V-Ray material. So I have a V-Ray material here. So this is basically like that with a little bit more. So you have your, it's broken up into tabs. So just to sort of compare it, then you have diffuse, which is that area. So you have diffuse and you have roughness. Reflection is here. We don't get subsurface scattering built into the primary shader, so we don't have subsurface scattering here, but the mantra surface gives you subsurface scattering. By default, you get 2 layers of reflection within the mantra surface, which is quite nice. And then you have refraction. Emission is self-illumination. You have the option that emission will give out light if you turn on GI. If you turn that off, it won't give out light. And then you have opacity, which is the same thing that's down here. Like in maps, you get an opacity map, so it's the same thing. And then in settings, you have, like, you can switch on Fresnel, which is the same thing as that guy. So if you switch on Fresnel reflections, so it's the same thing that you're getting here. Now as far as parameters are concerned, in reflection you have color and intensity. It's basically called specular, so because reflection is technically specular. Glossiness is called angle. So like if you come down, then you'll see it's called specular angle. So specular angle is the same as glossiness. And then you have anisotropy. But yeah, this is the primary material. Now if you look at clay shader, you'll see it has lesser parameters. If you look at surface model, it has even lesser. The funny thing is, these are all internally the same material. So if you jump into any one of them, it can look a little scary. But if you jump into clay shader, you'll find that it is technically using surface model. Okay, and if you look at it, then you'll see it has the exact same parameters. It's just what Houdini does is that when you build a node network at material level, and if you want, you can, of course, you can dive in and make changes, but you can also expose specific parameters for other users. So if you're just going to use 4 parameters out of the whole thing, then we can just expose that much and use just those and not worry about the rest. So what's happening here with the clay shader is they just expose these 3-4 things, and they're not touching the rest, but internally it's the same thing. So similarly, if I come to surface model, you'll see it has just 3 parameters, but if you come in and you'll see it is still surface model. Mantra surface looks a lot bigger because they've exposed everything. So if you come in here, you'll see that it looks pretty huge. But if you come in closer, you'll see that this is still surface model. So like this is a much bigger structure because they're exposing so much. Yeah, at the end of the day, they're all the same. So yeah, even though you end up thinking you're using different material types, they're technically the same thing. So when you're building something custom, so let's just get rid of these. When you want to just start from scratch and not do anything else, so you can just take a material shader builder and we'll just call it material 1, and you can jump in, and then you'll end up looking at this. So you have something basic, like you have a surface output which has color, opacity and normals. The F is for primarily it's for PBR. So for when you're doing physically based rendering, it has to be connected to this. Otherwise when you change the render type from ray trace to physically based and nothing is connected here, it won't render. So, and then you have these surface globals, which is basically a way of calling various attributes from the geometry, and then similarly you have you can output the surface, and then you can also output the displacement, and you have displacement globals for that. Again, even though the context type changes, a lot of the parameters are the same, and if you're not going to do displacement, then you don't need it. So yeah, and if you delete them, then you can always just bring them back. So these are globals and these are outputs. So if I type globals, so you can do global variables, and then by default it's surface, but then you can change the displacement, so you'll get the same thing. You also have fog and light, so you can create those guys as well. And similarly, if you do output variables, and then again if you change this to displacement, and then you can connect it to the second one here, and then you're back to where you were. And then once you've done this much, then you can just take a surface model. Now there is and this is kind of like a ready-made thing available, so we can just connect these two guys if you're doing ray trace, And if you're not doing ray trace and you're just doing PBR, then you can just connect the F to F, and then you don't need to connect these guys. So it'll just, you know, give you a result. But then the material won't show up when you're doing ray tracing, but that's fine because about 95% of the times I'm using PBR, so it doesn't matter. Now, now this is the even slightly bigger thing to understand, is that one of the things that Houdini does, it very rarely gives you like what would be called as a black box. You know, so like the V-Ray material, you can't really, you know, go in and modify this. Like let's say if I want an additional reflection layer, so I can't do that, right? I'll have to take a V-Ray blend and then, you know, add it that way. Here the interesting thing is that surface model itself is essentially like a digital asset. So, and it's a pretty huge digital asset. But if you go in and then you'll see that it's sort of done, you know, it's kind of a built up thing, which effectively means that you can, like, there are these nodes which are given to you. So like this is for reflection. So, you know, that's like the base, physically based specular node that is available. And this is for subsurface scattering, that is for diffuse. So that's the basic, that's the basic diffuse node. The point being that even the surface model itself is nothing but a collection of nodes, and these base nodes are also available to you. So you can sort of, if you want to build something really custom or really simple, and you don't need this much, then you can also build something that simple. And we will be taking a look at that towards the end of the series of how to build a really simple custom material if you want. So this is the basic. Now what we'll do with the next lesson is we'll start off by looking at how to build up a bitmap. So when we look in Max and have the standard bitmap, and like I'll just pick up something, you have a bunch of functionality for it. So we'll take a look at how to build all of that in the next class, and that will be a starting point. And then we'll go through as many of the Max maps that are available, like the traditional ones. So you have bitmap and cellular and fall off and gradient, and then you have, you know, mask and stuff. So all of those functionalities that you have available inside of Max, and then you know, how to create those or how to recreate those inside of Houdini. And then we'll sort of push it further and we'll see how far, you know, Houdini can actually take all of that. In the first lesson we saw the basic mantra surface, or, you know, what you can essentially call, which is something similar to the V-Ray material. The issue that comes here is that you can take bitmaps in this place, but you can only take them for specific things. So this is only a color map. So if I want to try and affect diffuse intensity, or if I want to map this particular thing or diffuse roughness, you can't really do that at this level. Also within the map you have certain set of parameters that are given to you. So you have like a tint intensity, and you have some basic filtering and things like that, but I don't have anything like tiling, or if I want to rotate the texture. So there are a lot of limitations to this. So what we'll take a look at in this particular lesson is the bitmap that you get in Max, and then you have a certain set of parameters in there, at least the basic ones. So you have offset and tiling and mirroring, and we'll just take a look at how to recreate all of that in Houdini. So one of the main things about Houdini is, like right now we have already given this some mapping, so you do have a gizmo, so we at least have that much set up. Now the basic material that we had created, which has a surface model in there. Now one of the interesting things about Houdini, or like one of the advantages and disadvantages of Houdini, is you very rarely have anything ready-made. So you usually have a lot of sort of granular nodes that are available, which you can combine together and, you know, build whatever kind of functionality that you want. So that is both sort of a blessing and a curse. So the blessing is that you can pretty much build anything that you want, and the problem is that, you know, sometimes you just want something ready-made and it's not there. But of course, once you build it for the first time, you can convert it to a digital asset and keep it. so that you don't have to repeat the process over and over again. Now, what we are going to do for now is I don't need the surface model. Now, this is something interesting about Houdini is unlike Max, where a bitmap has to be taken on a material and only then it can be assigned to an object. Houdini has no such restrictions, so you can directly take a map and connect it to the surface output and it will just do that. There won't be any shading, but you'll be able to see the bitmap. So let's get rid of this, and if you middle click on any of these, you'll see that you have options to take a texture map or take a surface color or take a ramp. So if I take a texture map, then you'll see that it kind of does some things for you, and gives it to you. So there is some amount of automation inbuilt into the system. If I was to click here and let's say take a checker, then again you'll have this stuff given to you. I personally don't use this very often, because what happens is that for everyone you'll get a new UV coordinate, which is kind of like what you get with Maya in Hypershade. So when you create a color map or something, then you'll have a separate set of a node for UV coordinates and then a node which has the texture parameters. So in a way this is very similar to that. But the problem that happens is that for each map you end up getting a new set of UV coordinates, and sometimes you just want everything to flow through the same one. So eventually you will have to start tweaking things. So you'll have to delete this and then connect everything here. So that is fine. But as I said, I personally prefer to just start building things on my own. What this has also done is it has also exposed certain parameters for you, automatically. So that is nice. But for now, I'm just going to delete all of this. So how do we start? So bitmap is essentially called texture map, or it's just called a texture. And you also get something similar called a color map. They both do the same thing. So they both do the same thing, except the texture has a lot more parameters. So you can take a map and then you have inbuilt filtering options. So you can use these. So you have a bunch of more options in here. You also have the option to take a ptex texture from here. Color map is a lot more simpler. So you can take a map and then you have like U and V parameters. So for now I'm going to just work with a color map because that's the simpler one. Now the first thing you need to do is you need to get your UV coordinates, and that's fairly simple. You can just type UV and you get UV coordinates. This is the ready-made thing that's given to you. There are a bunch of ways to get this. Like if you take a parameter, and this is a vector, so if I change the parameter type to vector, okay, and we just call it UV, and so this is effectively the same thing. What it is essentially doing is that on the object, if you middle click on it, you'll see that you have an attribute called UV, and that's what we are calling in over there. So like if you double click in here, you'll see that it's effectively doing the same thing. It's bringing up an attribute called UV coordinates, and that's being fed in. So this is sort of like, again, like a mini digital asset. But yeah, it's easier. You don't have to go through this process. So we'll just delete that. SNT is technically U and V, so you don't have to think about it. So wherever it says SNT, you're going to connect U and V. So this takes UV, so we can just connect this here, and that gives you the basics. And then we can connect this to our surface output. Let me open up a render window. Yeah, so that's what we have. So that's the default map that you get, which is the mandrill. Okay, so now we have to start thinking about other things. Let me just do one thing. I'm going to make the resolution a little smaller. Okay, now a second thing that comes up is how to start modifying the UV coordinates. Like how do we do tiling? So there's nothing here for tiling. Like if you select this or if you select that, there are absolutely no parameters for tiling. So the way it works is that if you again type UV, then you have a bunch of options that are given to you. So you have a UV transform, and you also have a UV position, and they both kind of give you options for scaling and stuff. So how it works is that you kind of add this in the middle. So this is the S and the T, and that goes in here. And now you get parameters here, so we can offset this, so it's 0 to 1 in an offset value. The issue that comes up here, which is one of the reasons why I don't use it, is that the scaling is essentially in decimal values, which is very weird. So if you want to do a scaling of 2 by 2, then you're essentially going to do a 0.5 by 0.5, and that will give you that. Yeah, it's not really fitting in properly. Let's try to do like a 0.4 by 0.4. Yeah, so like if I want to do 0.25, so it's a little difficult to calculate, like how much do I want to do here. The same issue happens if you're trying to do the UV XForm. Now the UV XForm doesn't take individual parameters, it requires the whole UVW, so you can just plug that in. Now the output is singular, so again you will have to break this up. So we're going to take a vector to float to extract the same S and T, and we can connect that. And again here, if I try to do this, this is scaling it up. It's not really what we want. I mean, of course it's called scale, so that's what it is doing, and this works better. The position was doing something different. This is a proper 2 by 2 scaling. You can also rotate it, so let's say we rotate it 45 degrees. Sorry, not here, yeah. So if I keep this to 1 by 1 and I make this 0, so you are technically rotating around this point. Okay, that's my 0 for both. So if I want it to be rotating from the center, I can do a 0.5 and 0.5, and see now it's rotating from the center. So the point is you do get a lot more options than what you would get with Max, and that comes in really helpful at later stages when you want to do something very complex. But as I said, you have to start building things up from scratch. Now again, this, as I said, is again an issue because I want the scale to actually work like tiling, because when we come to Max and then you have this, and I can just make this 3 by 3 and I'll get a tile texture, because that's what I want. So the best option that you get is called transform matrix, and that's the one that you should use. Okay, so it looks exactly the same, except the big difference is that if I do 4 by 4 here and I end up getting this, so which is a lot better, so which is effectively what I want. So that's the basic. So once this is done, in color map you have options, so you can have a repeat or you can have a streak, so it'll just stop here and then it'll streak out from there, and you can do a decal, which is just that texture and nothing on the side, and you can set the border color to whatever you want, so that's your background color. So think of this as your diffuse color, and that's my background. Now the other thing is, if you want to use this if you want this to have an alpha channel, I tried this out with like a Targa map and a TIFF. It works, but it causes issues. The best map to work with is using an EXR file. So we'll just build something simple. I'm going to start Photoshop. Alright, so I have this, and I have a 600 by 600 pixel image, and I'm just going to draw like a simple custom shape or something. So let's just come here. I'll adjust this to a 32-bit image, don't flatten. I'll get rid of the background altogether, and let me just do a save as. So I'll save this as an open EXR. I'll call it flake, and just do OK. So that's good enough. Alright, so the way this works now is you have a couple of options. So we can just let me just keep this to repeat, and I'll pick up that particular texture. So I'll just click here. Yeah, so I have flake.exr. Let me just render this. So yeah, by default it's giving me a black background. What you get is something called as a decal map, and if you put in you don't need a color map for this, because it has a texture inbuilt. So what it just needs is the UV mapping. So we'll just plug in these guys to S1 and T1, and the color comes in here, and so this also has a background color. So let's just set that to maybe like an orange or something. So if I hit render, right now there's nothing, it's just the mandrill. If I set it to repeat, Yeah. So if I change this to flake.exr and hit render, then there you go. So let me just make this a little darker. See, so now it's automatically taking in the the alpha channel that it had. So this is sort of like one way of doing it, which isn't bad. And it has options for positioning as well, so you can kind of offset the whole thing, or you can scale it from here itself if you want. Okay, you can also rotate it, which isn't bad either. So you have those options inbuilt at this level as well. Okay, another way of doing this, which is again, like as I with the thing with Houdini is that you get a lot of options. So let's just keep this to one side. We'll plug this back in. Okay. Even tiling, as far as tiling is concerned, like if you don't want to tile from here, let's keep this to 1 by 1. You can always do it in a couple of ways. So I can come into grid and I can just scale this down. So if I make this at 1 by 1, then you can do tiling here, which is fine. You can also lower the range here. So if I make this to 0.1 and 0.1, then you're tiling at this level as well. So you have options. You can also give it an angle here, so that works. The other way is you can also take a point SOP, and then within point SOP at the base of it you have texture. So if I do add texture, you get the UV coordinate. So if I do a multiplied by 3, and do a multiply by 3. So you can do, so if I take something like say a dollar T over here, multiplied by $T. So what you'll get is, as you start to increase, you'll see your so for every second you'll get tiling. Like if I just start to zoom it in, like if I start to play it slowly, then see, there you go. So you can actually animate this stuff from here. So you have options. That's the interesting part about this, that you have a variety of ways to do the same thing. Okay, now another way of doing the same thing that we did with decal is I can use it like a mask. Now the first thing is, if I want to get the alpha channel as well, then the signature has to change from RGB to RGBA, and then you'll end up with an error because that's a vector 4 and this just needs a vector. So you again get a converter called vector 4 to vector, and that will give me the color and the alpha. So I can go back to basic. Now what I can do is I can take a color mix. So the primary is the way it works is that the black value is the top color and the white value is the bottom color. So I'm going to take this and plug it here and keep this, and my alpha comes into bias. So this is sort of like building your own thing. So if I do a render now, I should get this, so I can take this to whatever color I want. Yeah, so there you go. So that way, so even if you don't have a decal, then you can kind of build it up like this, and then you can take something else here, like let's just take a normal color map. Yeah, and we'll just plug in SNT. So I don't want tiling for this one. Yeah, and we'll keep this to mandrel, that's fine. And then this goes into say primary, so I can get it like this. Yeah. But yeah, so that's how you have, so that's the process, you have to build it up manually. Okay, now one of the final things that we need to do here is how to set up mirroring. So that's a slightly different process, because that's not inbuilt. Like you don't have a mirroring option in here. So let's just get rid of this, and I'm going to take these guys here. Yeah, see the difference between color map, like I'll just create a snapshot of this and we'll take a texture map, or a texture node, and again just connect S and T here and connect this to color. So we have the same, like by default it loads up mandrel, but what you get here is, like if I change this to Gaussian, then this will be a little more blurry. You see, there you go, so it's a little more softer as compared to the previous one. Okay, or if I want to do say Catmull ROM, then that should be a lot sharper. Like if I bring this down to 1, or we can try like sync sharpening. See, so that's, yeah, there you go. So I mean, it's fairly visible how much sharper you can go with it. So the advantage of and it also has like a blur inbuilt, so you can do blurring, if you want to. So yeah, the advantage of texture over color map is having these things inbuilt. With color map you don't get any of this stuff. Okay, so let's keep this for now. Okay, so as I said, we want to create mirroring here. So what you can do is you get something called ramps, ramps, and this takes one of the parameters. So if I just take an S and I connect this, you'll just get like a black to white gradient, like that. You get a little bit of this repeat here because there's a blur value inbuilt, and you can't make it 0 because that causes issues. So you can make it like say 0.01, and that's fine, and that is still a little bit there, but it kind of goes away. So what I want to do is we'll plug this here, and similarly I'll do like a Control C Control V. This time I'll feed in the other one and plug that in. And now what I can do is if I select both of them, the frequency becomes tiling. So if I make this say 4, and then you'll get tiling. But now I can do mirror. So if I do mirror, then you'll get this. So that's how you can do mirroring. Like what's happening here is you're technically just mirroring the ramp value. So you're getting this. That's happening for you and that's happening for V. So yeah, so if you blur it a bit, then you'll see, like it causes a little bit of an issue in the middle, but that's fine. Like it's not very often that you need to blur or you need to mirror maps. So that's how the whole process works. So you don't need to do tiling here. Like I can actually bypass this if I don't want it. Like I can directly just connect S and T from here and you'll get the same result. I don't need this additional thing that's coming up. So yeah, so for basic tiling we can just work from here, and then if I want to like mirroring and stuff, then I can use ramps. And so all of this combined together then gives you the functionality that the basic bitmap gives you. So yes, it is it's a little more work than what you have with Houdini, but as I said, you can, once you've done this much, like let's say I have this much, or even if the interesting thing is, like even if I plug these in and I don't worry about frequency there, I can just use those guys to do just the mirroring. Like if I select these guys, I bring them back to 1 and I do the tiling from here. So this is say 4 by 4. Okay, and if I just come in here and I switch on mirror, then you'll get the same result. Okay, so even if you don't deal with this, it's perfectly fine. So what you can do is, once I've done all of this, I can actually just convert this into like a digital asset, or for now we'll just convert it to a subnet. So I can just do a Shift C, and the whole thing comes in here, and then I can just come in here and I can say edit parameter interface, and I can just bring up the stuff that I want. So I can say from nodes, and what I want is from both of these guys, I just want to pick up like the mirrored values. We can connect these. Let's do one thing. I just want to jump in here and let's right click, say copy parameter, and paste it here, paste relative reference. So they'll be connected. So I can just pick up from ramp 1, and I just want this, the first one, and then I just want other things. So I want xform, and I want translate, rotate, scale, and pivot, and we can pick up transform order and this. So let's just plug that in, and we can do accept. So there you go. So you have like your basic. We can rename these. I didn't rename them right now. We can just come in here and probably select these guys, and I don't want like in the label, I don't want that. Okay, so yeah, let's just call this styling. Yeah, so there we go. So you have your basic. So yeah, it's a one-time thing that you have to do. Okay. So there you go. So that becomes like your basic all of the UV parameter stuff that you get with bitmap, and you'll get all of that in here in one shot. So that is how you go about building the basic bitmap functionality that you have in Max and getting all of that into Houdini. What we'll see in the next class is we'll start going through some of the other textures that are available in Max, So we'll start off from the basic stuff. So you have like checker and a few others. Now that we've seen how to create the basic bitmap functionality, let's take a look at the other maps and textures that come inbuilt into Houdini. So we'll create another material shader and just drop it in. We'll call this textures. Now in this lesson we'll try and deal, like in Max they've sort of removed it now, but earlier you had textures that were broken up into two categories. So you had 2D maps and 3D maps. The essential difference was that 2D maps use the basic UV mapping of the object, and 3D maps sort of existed in object space. So for this lesson we'll primarily deal with the variety of 2D maps that are available. So to begin with, you will need a UV coordinates. So let's just keep that. And when you press tab, if you come to patterns, then this is where you will find a majority of your stuff. So if you press tab and come to patterns, and these are all the variety of patterns that are available to you. Now there are certain noise maps which we will look at in another class, but we will try and take a look at a majority of these within this chapter itself. The most basic one would be checker. Okay, so this generates like a basic checks pattern. Now the big difference here again is this will generate a checkered pattern, but there are no values for color. So the way it works is once you connect your UV to this, yeah, and if I directly connect it, we'll get black and white checks. And you have a tiling value inbuilt, so you can always just control it from here. So which is nice, but you can always just put a transform matrix in the middle and control it from there as well. So there are no limitations in that sense. So tiling can happen from here, or you can modify it in the middle. That's also fine. Now the way it works is you can do one of three things. We can take a color mix, and this can be used as a bias. So these three things combined will now give you what is basically a checker map. So that is one way. Another is we can use something like a ramp parameter. So we can take a ramp parameter, and this is going to generate a gradient, but the thing is you won't see the parameters or the values here. This is something that shows up at the top level, not inside wops. So once you connect it, and this will also generate a color value. So default is black and white. If we come up here, then you get your two colors. So whatever you want to set. So that's one way. Those are the two basic ways of doing it. So let's just get rid of the ramp for now, and we'll just keep it to color. Now beyond this, we can also use something which is called as a rainbow. Like if you type rainbow, then you'll get so what this does is by default it requires some kind of an input. Like if I just connect this here, you're not going to get anything. I mean, it'll just create repeat patterns. What it is doing right now is it is mapping to every polygon. So if I was to come here into my grid, and this is I believe this should be 10 by 10, and if I lower it down to 2 by 2, you'll see that that automatically modifies. So it's not really using the UV coordinates. So if you feed something into this, like if I feed the vertical, the V value or the U value, then it will generate something based on that. But if I was to feed the checkered pattern, then it will sort of fit it based on that as well. So it can use any kind of black and white values coming in, and it will generate like a rainbow pattern on it. You can desaturate it a bit. This value will make it darker, so you can go all the way to black, and this sort of just makes it go towards white, like if there's nothing in there. Let's just keep the color mix to a side, and then we'll just use rainbow for now. So that's the basic. Let's get rid of these guys as well. We don't need these at the moment. Okay, then if we come into patterns, you get, to start from top, you get boxes, which is going to generate like a tiles map. So if we connect the S and T here, and you get amount. Okay, so if we connect that, you'll basically get this. You can, again, you have tiling in here. S and T frequency generates tiling. So let's just make it say 5 by 5. You can adjust the box size. So there you go. You get a couple of interesting things in here, which is you can
Offset of course is simple, you can just move it to a side, but you can also randomize the movement. So if you just want to generate a little bit of randomness to it, it's quite nice. So if I make it big enough, you can also blur it. So if I get it to a blur of say 20, you'll see, you know, it kind of blurs out a bit. Let me just, connect this here directly to show you. See, so it blurs out. And of course you get, your filtering types. Now this is generating the basic tiles functionality. But with the tiles map inside of Max, you get a lot more. Like you can randomize color values here as well. So in a later class, we'll see how to build the entire tiles map functionality. So this is just the basic sort of like a beginning block for the whole thing. You can also randomize the size of each one. It is quite detailed and well thought out. Okay, let's get rid of this. Okay, then you get cellular noise, which is basically like a 2D, Voronoi pattern. So if we connect this here, now you get different options. So if you just connect border, you'll get, simple break patterns. If I increase this to say 5 and 5 again, so there you go. You can define the border width, how much you want. You can define the border softness. So again, let's just make it about 5. So there you go. So you can do stuff like this. But then you get the other thing. So you can do like distance 1, which gives you this. You have distance 2, which gives you that. And you have so all the different sort of Voronoi patterns. So yeah, you have S and T center, which is sort of generating, like a UV pattern again. Like if I connect this, you'll see you're just getting like a black and white value going, in two directions. We'll also see how to use these things at a later date, at a later stage. So yes, you have, like a variety of options coming out of it. Okay, then a couple of others that you get something like a burlap pattern, which is just going to generate, sort of straight lines on the whole thing. So like a crisscross pattern. And then again, now you don't have any rotation options here, but if I take a transform matrix, like I can't rotate this, but I can take a transform matrix, do a vector to float, and then I can rotate it here. So if I make it 45, see, so you can, rotate it this way. So you don't have certain functionality here. You can always just, build it up to other means. Okay, another type of anything that is basically with noise, we'll take a look at in another class. But you get another type of checks which are called gingham checks. So again, you can just connect, S and T over there, and so that's what it looks like. If we now, but again, like the check size is sort of dependent on decimal values, which is not something that I like. The pattern itself looks like this. Like if you connect it here, so there's sort of like a semi-gray faded out thing. You have a blur value. You have to increase it a fair bit to start seeing what happens. Yeah, so there you go. That looks interesting enough. So you do have a variety of maps and textures that are available. Okay, then here you have about 4 or 5 of these. Okay, I'll like ramps we saw yesterday. You can also use it for generating textures and patterns. You have rings again, which is sort of like boxes. The parameters are very similar, except that it generates like a hollow circle. So if you connect this, so there you go. You can define the ring size, how much you want. Again, you can define frequency. So yeah, so those things are fairly similar. You have ripples, which are concentric ripples. You have rounded hexes, again, very similar to the previous one. So yeah, very like, of course, here things get a little interesting. If you lower the hexness, it becomes a circle, and if you increase it, it becomes like a flower or a star. And you can also modify the sharpness. See, so if you lower it, you get something like this. If you increase it, it becomes more of a flower pattern. So you can actually use this to generate flowers, if you want. Let's just keep it to one side. We will modify these guys a little later. First, we'll just, quickly go through a lot of these things. Let's get rid of this. I don't need that. Okay, similarly, you have rounded stars, you have scales. Now, some of these might actually be okay. So if you take a look at say something like eggshell pattern, then there's a good chance that this is essentially like a subnet, or a digital asset. So some of these are essentially digital assets which you can then go into and study and figure out if you can use these. So again, like if I connect here, this is scales, it generates, another. It also has displacement functionality inbuilt, so you can connect this into displacement. We'll take a look at that later. So there you go. Lower the frequency to 3 and 3. Let's just take a look at the basic stuff. Yeah, so that's what it looks like. So again, you have shape values given to you. Now, the interesting thing that happens here is, unlike Max. Okay, so okay, let's just take a look at final 2. So you have soft dots. Again, the basic parameters more or less remain the same. So you'll have like a randomization value, you'll have frequency, all of those things. Yeah, so these are like, generating softer dots. One of the interesting things that happens here, literally every single value can be mapped, which is not something that you can do with Max. Like in Max, you have maps available wherever you have color data or in some of the numeric values, but like I can't map noise size, or I can't map tiling. So you have a lot of things which you can't essentially map out, or like if I have a checks blur value, or something like that, then you can't really map those things. With Houdini, you don't have any of those restrictions. So with Houdini, literally anything can be mapped. So like, let's say if I'm bringing in my, my hexes over here, and let me just lower this a bit so it opens up. Yeah, and currently the color that is being generated is just, it's taking the black and white values and fitting in whatever it can. Let me blur it a bit. So I'm just going to take it about 15 and just change this to Gaussian. Yeah, so it blurs a little more. So what I can do is I can use something like a fit range. A fit range is just going to modify, whatever values are coming in to a newer set. So by default, it's going from 0 to 1, and the newer values are also going from 0 to 1. But if I start to increase this, then what it is doing is technically your map has changed to this level. So now instead of fitting the black values, it's fitting in the gray values. So you can get a different, area from the rainbow. So again, modifications are pretty easy. But the more interesting thing that come up is you can sort of modify almost any of these parameters. So you're not limited to just, color values and things like that. So let me just keep this here. But let's say that I want going from, left to right, that they should be hexes here and then they should slowly turn into flowers. So if I just take the S value and connect it to the hexness and see, so that's basically what's going to happen. If I put it through a fit range, it will be a little bit easier to control it. So let's just put it through a fit range and we can kind of adjust it. So let's say it's 0 to about 0.4. So you can kind of adjust that. And then this is for adjusting, like nothing is happening from here to there. Let's keep it to about 0.2. So it is a, a little bit of a hex. And let's just increase the frequency a bit. Let's make it say 8 and 8. So you have a few more. Yeah, see, so there you go. So you have like a pattern which is modifying with range. Similarly, let's say if I'm doing randomization, so these are both. Let me just modify the size a bit. When you modify if the size is at 1, the randomization doesn't really show any effect. So you just have to lower because it needs space to move. If you don't give it space to move, it won't really be able to do anything. So you can modify these kind of things very easily. So similarly, like if I take a check, if I take a checker pattern, and let me just do a Control C Control V here. Let's say I want, let me just try to fit this in here. And let's say I want to modify the tiling. So let's say it's 3 in the beginning and then it becomes say something like 10. So if I was to plug this in into S frequency, see, so you'll get, like you have lesser tiling here and then it kind of increases. Or let me just keep this to 0. So you'll get like more stretched. So if I apply it to say, okay, let's try to put it to, yeah, so you can start modifying things, make them a little more weird. Yeah, and let's say if I come back into my grid and I put this on a sphere. I'll take a sphere, make it polygon, and then we'll again take a UV project, but I'll make it polar. So if I press enter and then I'll just do an initialize. Yeah. So let's, it should have updated. There you go. Now this particular seam that you're getting here is basically if this is kept to points. If you change it to vertices, see, that will go away. So you might get like an issue with seams. See, so there you go. So you have like, lesser at the base and more towards the top. So it's very easy, or it's very nice to be able to do something like this. Like the point is, you might not have thought of it before, but you kind of go like, why not? If the software is giving you the capability of doing it, then it's always, a great idea to try and do it. So yeah, let me just go back to the grid. So similarly, like if let's say I want to come into cellular noise and I try and do something similar, so we'll take, another fit range, and I want to modify, say, the width of it. Okay. So I can just take this and I can, connect it to the width, and so what I can say is that, okay, so, in the beginning and then towards the end, see, so you're effectively generating sort of like cracks, so if I take this to say about 10 and 10, see, so you have like, thinner cracks and then it disappears. And then we can also try to adjust the fit range, and let me just try and go into negative. Yeah, there you go. So you can sort of make it disappear completely. So if I make it minus, say, 0.1, then you don't have any cracks here. You have a little bit, but not a lot. See, so you can do stuff like this, which is, much more interesting. And if I modify this into say something else, so if I was to, okay, let me keep that. Okay, this is starting to look a little bit complex. Let me just get rid of, and let's say I take a ramps parameter, sorry, or a ramps, that one. Let's plug in the t value here. Let me just take a look at it once. Let's increase the frequency to say 3, or to 2. Okay, and let's try to mirror this. Okay, so what we should technically have is, if we look at it in black and white, is basically this. And so let's say I want, like, cracks in the middle and nothing on the side, or we want cracks on the side and nothing in the middle, then this can be used. So I can plug this in over here, and we don't have this, so let's do that. There we go. And if we reverse it, so if I just take this here and take that there, so if you want to do a road which has, cracks on the side, and then, it's nicer in the middle, then we can easily do that. So let's make this about, say, 20 and 20, and there we go. And you can define how much you want, so that's always nice. So you can, so the nice part is that you can kind of do a lot more complexity with these guys, that you hadn't really thought of before, because you can map almost, any particular value that comes into your mind. The other thing which I like about cellular noise is also that if you lower the S and T jitter, it basically goes back to being, a grid. So you can kind of, modify those guys as well. So if you want to do like a city pattern, like let's remove this, and we just have that, and we want to show like, okay, you have a grid, and then slowly it starts to randomize a bit, then I can just take this and say plug it into T jitter. Okay, see, so you're getting like a little bit here or a little bit there. Let's just plug in the basic thing here. Okay, and then if I try to increase this, see, so you have like, randomization starting to show up. Let me lower the count, so let's make it about 6 and 6. See, so you have, more straight lines. If I start to adjust it, see, so it's more straight, and then it starts to randomize up there. So you can do these kind of things very nicely. Later on we'll also see, like, if you generate like circular patterns, then we can kind of use those to modify. So like if let's say I take something like a soft dot, and we'll plug this in here. So maybe you want to do like a circular thing, so let me just and let me just take a look at this once, what it's like. Yeah, okay, so that's perfect. Okay, so let's say that instead of just fitting in a straight gradient, and let's make this say 15 and 15. Yeah, so if I fit in this over here, and let's say that goes into S and T jitter, okay, then see, so you have, randomization sort of happening in the middle, and then nothing happening on the sides, because the basic version of this is essentially just like a soft dot, so you have randomization in the middle and then nothing on the side. So this kind of modification or the capability to do this kind of modification becomes very nice. That you can sort of adjust it a lot better. And then we can also reverse it from here, so it's more uniform in the center, and less on the sides. Or like, if we want to fade it out completely, then we can try to, plug this into width as well. So I can just take this and say we'll plug it into width. Okay. Ooh, okay. That looks that looks interesting. But yeah, see, so if I don't want anything on the sides as such. See, so you can, so the point is the options sort of become, much more interesting than what you had with just with Max. You have, certain parameters that can be mapped, and there's a lot of it that cannot be. With here, there's almost no limitation, so you can kind of map almost anything and generate like a whole bunch of whole variety of things. And the more interesting thing is that you can also bring in attributes or parameters from geometry level and have those influence it. So we'll also see an example in a later stage, if let's say you have particles falling, and those will start modifying the texture. So you can always do stuff like that as well. So that is also pretty neat. So anything that you are generating, any kind of a texture can be modified using any number of attributes that you can. So these are the basic these are the basic 2D maps that are available. There could be a few more, you can sort of just, go through them. But in the next lesson, we'll start taking a look at, the noise maps that are available. A lot of them are fairly similar, but yeah, you have like your Voronoi pattern here, and then you get what's called as a turbulent noise, which is your basic noise map, and a few others. So we'll take a look at those, and then we'll also see how you can modify these guys using those particular patterns. So yeah, so these are all the variety of 2D maps that you get, and how you can map any particular channel and modify them to create more interesting patterns. So in the previous lesson, we saw what could effectively be called as 2D maps, or maps that would usually use UV mapping to generate coordinates. Now we'll take a look at what Max used to earlier call as 3D maps. So effectively, stuff like noise map and cellular, and there would be marble and dent and those kind of things. So we'll just create another material shader and drop it over here. I'll just call it 3D maps. They're not really called that here. They're not even called that in Max anymore. But it's just sort of an easier way to relate to things, for especially for people who've been using Max for a very long time, so who would still remember that there were categories like that. Houdini provides a fair bit of or a fair variety of noise maps. Some of them are quite similar, so it's a question of which ones do you want to use. I'll mostly try and cover the ones that are unique enough, or the ones that are used more often. So if I come to patterns, then the most common one that I end up using is turbulent noise. That's the one that I generally go to. Now here again, we can connect it to UV map. So the position, you can take a UV coordinate, and you can connect it to a UV map. So if I come into my object, and let's say I switch over to my sphere for a moment, let me set up the render window again. Yeah, so we have this, and again I'll just set it up with a ramp, which will be easier. So ramp parameter, and there we go. So we'll end up with this, and you'll get a seam, because naturally, I mean, it's a it's setting to UV coordinates. But if you want to set it to like object space, then instead of taking UV coordinates, we can directly, if nothing is connected, you're not going to see anything. So if you just connect it this way and you see nothing, then that's your mistake. You need something, either UV coordinates or the position coming in from the surface globals, to be connected to position. Otherwise nothing's going to work. So you can take position and connect it here, and now it's now it's going to behave like an actual noise map. So you won't, it's going into object space, you're not going to get a seam or anything. There is one major issue that comes up with this. It's a fairly common thing, but if you're new to Houdini, then it will definitely pose a problem to you. If I start to rotate this around, you'll notice that the map isn't really rotating. It's actually doing a weird thing. It actually sort of like bulges in and out. And it also changes if you try to zoom in, zoom out. Like if there you can see the whole thing kind of. So it's not really sticking to the object at all. Okay, it sort of keeps swimming all over the place. Even on camera movement, it swims. So what needs to be done is you need to give it a rest value or a rest position to make sure that it stays locked into on the geometry. So you can just take a rest. So there is something called as a rest position, and you can put it in the middle. And that's it. You don't, I mean, it has some parameters, but by default it goes to object space, and that's great. You don't need to think beyond that. And now if I rotate it around, see, now the map is exactly where it should be. So this particular thing is extremely important. I have mentioned it before in a couple of my lessons, but if you don't have those and this is the first one you're watching, or any which way, the point is it is a very important thing, and don't forget to do this. It would be nice if this was sort of automated or it was inbuilt, but it has to be done. So that's your basic way of setting it up. So any kind of whenever you're going to use a position from here, there'll always be a rest position in the middle. Okay, so moving on, let's just quickly take a look at the parameters that are available. You get a fair variety of noise types. When it is 1D, then it's just sort of exporting values from 0 to 1, and you'll get what you're getting is technically this. If you change it to 3D, then you'll get like a more of a colored noise. But yeah, default you end up using the 1D stuff. Okay, so starting from top, you get Perlin noise, which is much more sort of brighter, and you have original Perlin. So where you have values which are going like completely into black. Now these can be remapped. You have methods by which like areas which are completely gone, you can sort of bring them back, and we'll just take a look at them in a second. Sparse convolutions, you have a whole variety of these. Alligator noises, the name comes because it's supposed to resemble the skin of an alligator. If you plug it into a displacement, you'll see the similarity, which again we'll do in just a moment. You have simplex noise, which again looks like this. You have zero centered Perlin. Now, in order to, like, by default it's going from 0 to 1 and you're getting like these, but there are values internally as well, or going below 0, which we're not being able to see. So if you want to adjust the range of that, you get something called as fit range unclamped. Don't take fit range, I'll explain the difference a little later, but especially when you're working with noise maps, always use a fit range unclamped. And if you put that, then if you take the source value and instead of going from 0 to 1, if I get it to say minus 0.5 to plus 0.5, and now the results are much better. So if we take this as well, and if I get this all the way to minus 1, or yeah, see, so it's just easier to bring things back, or you can increase this. So this if we go from say 0.5 to 1.5, that's a better result. Or if we take original Perlin and we go between say minus 0.5 to plus 0.5, and then it gives you a better result. So you can always put a fit range unclamped in the middle and then use those. So yeah, all of them you'll definitely see like have a much better result now. Okay, let's just quickly take a look at the parameters for these. Let's do one thing. I want to just assign it to a plane, so I'm going to switch back to a plane again. Okay, so sometimes you'll end up seeing like a pattern showing up, like we're getting like this line moving from here to there. The problem is because the offset values are completely at 0. So if you sort of just move it out a little bit, like even to 0.1, you'll see that pattern mostly disappears. So yeah, generally don't have values on 0. Keep the offset values slightly offsetted. They work out better. Okay, so frequency is sort of like density. So the more you increase it, this is noise size. If you look at it from a max point of view, this is noise size. The higher it goes, the more smaller the noise patterns get, and the lower it goes, the larger the noise patterns get. You have amplitude, so if this is at 0, you'll get nothing. You have roughness, which is again, which is basically like quality or detail essentially. So the more you increase it, the more noisier it gets. You have attenuation, which is sort of like contrast. So if you make it 0, then you'll see, you know, patches. So kind of like the high and low values that you get in max. So if I just lower this, you know, and then we can lower that over there. See, so if you want to do like stucco or something, then you can use patterns from here. See, there you go. That's like stucco, the map that you get in max. And similarly, you have turbulence, which defines, you know, like if the turbulence is high, the roughness will start having an effect. But if the turbulence is very low, then that's sort of like the cutoff point. You know, like if I say maximum you can go up to is 4 iterations. So then even if I increase the roughness very high, you know, and the turbulence itself, you know, is only set to 2, then it won't be able to go very high. So the turbulence value is pretty important because that defines the range of the roughness parameter. Okay, so we have this. Let's do one thing. We'll also set up a displacement. So because you know it works much better if you have displacement. I had previously added before the lesson. I added like a simple like an area light here. The parameters aren't changed. It's just a basic area light because you want when you if you're going to do displacement, it will be better to have an area light so we get shadows. Okay, so setting up displacement, again, if you're completely new to Houdini, then there are a couple of steps that need to be done. The most basic is you need something called displace along normal, and that will generate displace. So that's pretty straightforward. You know, you don't need to do anything beyond that. So I can just take the noise map and connect it to the amount here, and you have position and normal. They both need to be connected to the output, and that's basically it. But the problem that happens with that particular thing is if I try to do a render, okay, just one more thing. Let's put a shader in the middle, and I don't want this to be black. Let's just make it gray. Okay. Yeah, so we have something called as the lighting model, which is like the really old, you know, standard material that used to come in Houdini. It's still there. So we can just connect this to diffuse, and then we'll connect this to color. And so you'll have shading. Now, that's your problem. Let's also do one thing. Let's get rid of attenuation so we are back to something more normal. But yeah, you can see it's sort of just completely breaking it up, and that's not what you want. So what is happening is that as it starts to displace, the individual polygons or the micro polygons start to sort of break apart. And the way to correct that is you need to add an additional thing. There is a parameter in there called displacement bounds, and that corrects this thing. Now it can be done at two levels. You can do it on a per object basis. So if you come to your grid and then you can add it somewhere here, which is fine. Or if you just wanted to globally affect any object, then you can just put it inside your material. So which is what most people do. It's just easier. The rule is that the displacement bound value should be equal to or higher than the scale value. So in the displacement scale, this should be equal to the displacement bound. So the way it works is you take up a node called properties. So you'll find properties and come to edit rendering parameter and just directly do a search because trying to navigate through this is a bit much. So just do a search for displacement bound, and if you come to mantra, then you'll find in shading you'll find displacement bound. So just add that, hit apply, accept, that's it. And then take the scale value from displacement, you do right click, copy, come to properties, connect this to the third output here, and right click and paste relative reference, and that's it. Now if you hit render, you'll see a much, there you go. So everything suddenly, you know, works out a lot better. So this process is very important. If you don't do this, you're going to start seeing problems. One of the nicest things about Mantra is that it handles displacement extremely well and really fast. You know, as compared to V-Ray or any of the others, that's a genuine strong point of the renderer. Yeah, let's lower the frequency a bit now. And now we can start seeing the difference. So if I lower the roughness, so there you go, you know, that's your roughness. Let's just increase to 4. So if I increase this a little bit, you'll start seeing, you know, more detail into the whole thing. Yeah, now I can just let me just try to set this up a bit more. And if we lower attenuation, then say I said you get like these, peaks and valleys, much more sort of sharper. So it's kind of like contrast. Like if I get it really low, then you'll actually get like blocks. So wow, okay, that's looking very weird. Okay, so now if we check the other, so you have sparse convolutions, which you know is that, and yeah, alligator noise now should give you something more interesting to look at. So that's what alligator noise looks like. So that, thus the name. So if I increase this, let's do one thing. Let's just put this into, yeah, let's do one thing. Let's try and put this into a rainbow. That always looks more fancy. So let's plug this in from here and bring it into my diffuse color. So yeah, there you go. That looks fancy. Or we can try to put it through the fit range. Yeah, because this is sort of rescaled, so we're getting different areas to work with. Yeah, so you can adjust it a fair bit, that's one of the nice things about it. Okay, so this is the basic noise map that you'll get. Okay, now the other ones that you end up getting, which are, okay, let's minimize this. So you can click on the first one that will minimize it. The basic cellular pattern, you get two of them. You get Worley noise and you get Voronoi. The results are just a little bit different, but on the whole they're very similar. Let me just stop this. So I'll connect to Worley first, and you just get frequency and offset. You don't really get much more than, you have two types. So you have, if you connect distance to this, let's hit render, see what we're getting. Okay, let's just lower the displacement a lot. Yeah, so you'll get this as a basic. And if we connect distance 2, then you'll get something that's more sharper, so something that's more closer to so you have two types in cellular. You have circles and chips. So this is chips. The big difference between Worley and Voronoi at a very simple level, without really going into too much detail, is the height is a little bit stronger in Worley. It's a little more sort of gentler and spread out. But I think those things can, again, you can sort of adjust them. So if you spread it out, or get this back up there, yeah. But the one main thing that you get, which is different, is you get a jitter value, which is very similar to the cellular 2D map that we had done before. So if you get this to 0, you'll basically get a grid. You'll end up with this. So it's easier to do, slightly more, like if you just want to do a slightly broken up grid. So if I get this to about say 0.3, 0.3 and 0.3, and that's kind of more better or interesting. So if I just keep this, take the second one, which is more sort of rectangular. So you can do like this, slightly offsetted grid pattern. So if this is at 0, you won't get anything. So that is something that you can't do with Worley. Voronoi is kind of better for that. So it's nice for doing floor patterns and things like that. And if I take the ramp and just, see, so kind of like the pattern you get on, floors of lifts and things like that. Yeah, so you can do, so yeah, you can generate quite a few sort of patterns and parameters out of these things. We'll go negative with the displacement, see what we get. Yeah, there you go. So that's interesting. Okay, so those are the primary, like the noise map and the cellular map. One of the more interesting ones that you get with Houdini, beyond these guys, is something called as the unified noise. So the unified noise is very nice because the unified noise is essentially a combination of everything. So all the various noise patterns that are available inside of Houdini, are there in unified noise. So if you don't use any of the others and just use unified noise, it's the result will be the same. It has more controls, and overall it just works better. So I just wanted to show the other ones before, because sometimes they're simpler and unified noise has a fair bit of parameters. So sometimes you just want a simple result, you can work with these guys. But yeah, on the whole, unified noise will give you the same result, just with a lot more control. So let's connect rest position, and so you just have a noise and we can output that. So yeah, I think let me just get this back to normal. Yeah, I'm going to temporarily turn off displacement. So just take displacement and make it 0. So we have nothing, happening there. It'll render a little faster. And I'll also replace this to rainbow. So you get like a little more colorful result. So, and let's keep this to 0 and 1. Okay, so starting off from top, you have the basic frequency and offset value. Again, just sort of shift it slightly, so the result is a little better. And then starting from top, you pretty much get everything. So you have purlin, you have these guys. Sinusoid is basically like a wave pattern. Like if I connect this, and let me just adjust the range a little bit. Okay, if we lower exponent, that sort of like, yeah, there you go. So that makes it sort of more sharper. And if you increase it, it sort of blends out a lot more. Let me just try and see if I can push this a bit. So let's make this about 3. See what we get. Should get something at 3. Yeah, there we go. So you have like a, so you have sinusoid, you have purlin, which is fairly simple to understand. This is like the basic noise map that you get with Max. So you have like regular fractal turbulence. So that's like regular. Complement primarily turns the whole thing upside down. So if we kind of check it, see, so that was up, and in complement, see, it basically does this. So if you notice here, then that was down, and without complement that is up. So it's basically flipping the whole thing. Fold is very similar to the turbulence map that we generally get. So if you check this and I switch on fold, then you'll immediately see a resemblance to, that's the turbulence pattern that we get. Again, if you lower the exponent, it's sort of, like lowering the blend between the colors, so it starts to become a lot sharper. Yeah, then you have periodic Perlin, which is also sort of, going to generate like a wavy, a straight out wave. Simplex. So you have like a whole variety. So everything that, like you get the Burcon map with Max as a plugin, and which has like this huge variety of noise maps. This is sort of similar to that, so you get like a huge variety of them. You have flow, and when you come to flow, you also get a new parameter which only activates then called flow rotation, which is sort of like the phase value. You'll get like a much more smoother result. If again, I'll just turn off displacement for 1 second because it does slow down calculation a bit. And if I just move through it, so see, you get like it's like a seamless flow pattern. So if you just want to animate noise, so it's very similar to, as I said, it's similar to the phase value that we get in Max. So periodic flow, again, this is more straight. You get Whirly again, which is your cellular pattern. You get Whirly F2 minus F1, which is more of blocks. This is particularly good. It's much better than the basic Whirly map that we were getting, because the values are a lot better. You get much more control, and if you start to adjust the exponent value, you can get some very nice results out of it. So if I bring up my displacement to say 0.4, and you'll see, there you go. So you have these very nice flagstones and stuff like that. So uh, this gives a much better result than what you are getting otherwise. The artifacts that you're getting, they can be improved by adjusting the dicing values here. So you're getting like these, the step pattern. So if I increase this to say 3 for now, then you should be able to see that goes away. See, that's gone now, sort of. So when you're getting like these kind of patterns, then you can just improve quality from here. Right now we're just testing, so we don't need to. Okay, let me just adjust that a little bit so it spreads out a bit more. Okay, you get a couple of other things here, which is basically like a lattice warp and a gradient warp. A lattice warp is more of a distortion. So again, if I just take my displacement and yeah, I'll make the displacement 0 temporarily, so it's just easier to see this. Okay, so lattice warp essentially creates more of a distortion effect. So if I just increase that, and see, so there you go. So the whole thing's and if we increase frequency, let's make it about 3. So you'll get more of a, see, you get more of a broken up pattern. Gradient warp is more of sort of like it bulges the entire map. If you go into positive, and if you go into negative, it sort of like, just pulls it all together. So it's like a bulge and shrink. It doesn't work very nicely with cellular. If I increase this, it looks very strange. Like if I increase that up, and you'll start seeing like really weird. See, it becomes like this. It looks fancy, but if you do displacement with it, it looks terrible. If I push it through rainbow, you'll start seeing something more interesting. See, I think it's nice if you're doing crystals and stuff. Just give me a second. Let me just get back to zero here. Yeah, see, so you get like, it looks nice. You could probably find a use for it somewhere when you're generating patterns or designs. But yeah, that's what it does. But it looks much better if you do it with, like let's just lower exponent a bit so we can see what we're getting. Yeah, and if I change this to, okay, so if I change this back to say something like Perlin, then the effect should be much more apparent. So if I increase my gradient warp, and see, so you can start seeing like these bulges, happening in places. If I just take the basic ramp, it should be easier to see that. Yeah, see, so there you go. So if I increase the exponent, and you can see like these, bulges happening inside. Now if I go negative, it'll be a reverse thing. So it's sort of like everything starts to squeeze together. So it's an interesting effect. You get a lot of, a variety of ways to deform and distort noise maps. So there you go. That looks pretty interesting. Okay, and finally you get uh, a variety of fractal types on top of it. So you have your basic standard, which is FBM, that's fractal Brownian motion, and that that'll add like the roughness values on top of things. So let me just turn these off temporarily. Yeah, so again, so max of octaves is like turbulence. This is like fractal level, so the more it increases, the more iterations that you're getting. Again, if you start seeing patterns like these, you can try working with the offset value, and that might help. Yeah, and then of course you have roughness. So if you increase it too much, then it just, everything just turns into noise and you don't see anything. So yeah, it's quite helpful. Like if you're doing, again, if you're doing Whirly, then you get like additional details on top of everything. So if I just go back to the basic black and white, you should be able to see it. Like if we come closer, see, so you have like, more of these on top. Okay. And then if we add, lattice warp on top of it, then you'll get, the whole thing sort of breaking up. So it's really nice. You want to do like a cracked mud or a cracked earth kind of a situation, or a texture like that, then this is very, very cool. Okay, to work with that. And then you have options like you can accumulate it, so it sort of like, become more intense with every iteration. Let's bring up the displacement. Yeah, so it'll get a little slower because now we have a lot of detail, but there we go. So if I just come up here and, let's say if we just change this to like a brown or something, and if I'll just do one last thing here. So let's just lower the exponent so it doesn't blend out as much. So we'll just bring this down a bit. So you want like more sharper, cracks on the whole thing, and then we can increase it. So there you go. So these are the three major, noise maps that you get. There are a couple of smaller ones we'll take a look at, in the next class. So those are fairly simple, which have like specific usages. But the unified noise is the primary thing, that will sort of help out a majority of your stuff. You have another set of options in unified noise, which is called output, which is sort of like an inbuilt fit range kind of a thing. So, you can adjust things like bias and gain, internally, which is nice. And like if you adjust bias, so I can make it, see, I can make it darker or brighter. Okay, so you have these options which are inbuilt, directly. So even if you don't connect a fit range, you can adjust a lot of things from here. Like we can switch on complement again. So which is, again, so you can flip the whole thing. So if you want this to be like veins, and now if I increase this to say about 0.3, and then you'll see, so you can get stuff like so you get a lot of stuff which is inbuilt that you can then adjust. And then again you have output range here as well that you can adjust, and you have a complete amplitude value which you can take care of as well. Okay, so if I make this 0 in x or in 1, yeah, so it'll just disappear completely. But yeah, so these parameters you have inbuilt. So this is the best option that you can work with. Gives you like a whole range of stuff that you can do, and in general it's sort of much more easier to work with. Like since you have a lot of options, it just makes the whole thing a lot better. Like you have all the options in one place. You don't need to have 3 or 4 different maps that you have to go through to get a variety of effects. So yeah, in general, it's better to work with unified noise, and then you have the other ones as options that you can use. Yeah, there you go. So that looks. If you connect this into into like self illumination or something, you can get really nice effects with the whole thing. So yeah, in general, a really nice map, and you can generate a whole variety of stuff. So as I said, in the next class we'll take a look at a few of the other simpler 3D maps that are available.
Now that we've seen the unified noise, let's take a look at a few more things regarding noise maps, or 3D maps in general. So I'm going to create another material, and this time I'm going to use a sphere. Now I just want to set up displacement, and I'm going to copy and paste it from here. So I can just take these two parameters, or these two nodes that we have. So just do Control C, and we'll come into warp material and Control V. So the nice thing is that the reference parameter is automatically set up, so we don't need to worry about that. And then we can just plug these in. So this comes here, and these two get connected. Alright, and let's just make a floating panel. Alright, so let's just set up a surface model. So we'll have a proper material for this one. And let's set up a turbulent noise for displacement. Yeah, let me just stop this for a second, and we'll take a ramp. Okay, so we have this. Now along with turbulent noise, I'll connect this to displacement as well. So yeah, let's just bring that in to amount, and let's increase frequency so we have a little bit more, and let's get rid of, so we're getting rid of reflection so it'll render faster. Right now we don't really need that. Okay, now similar to the turbulent noise, you also get something called as the high-low noise, and that's actually pretty decent for doing terrains. The big issue is, like, if you connect it just to color, like we'll turn off displacement temporarily, and I'm going to just connect this to color. So we'll take the amount and connect it here to ramp, and you won't really see much of anything because the initial value is so low that you don't really get any kind of result. Like there is something, if you connect this to displacement, you'll see what is happening because there's enough there for displacement to activate. So you have these very minor bumps sort of happening, and if we increase the chip amount to say 8, there you go. So now you're starting to see something. According to the Houdini help, you want to go to at least 150 for it to start working. So if I jump this up to about say 170, and then we should start seeing something. Yeah, so that's effectively what you're getting. And let's just lower the frequency. Yeah, now sometimes you'll notice that the frequency is so low, but you still have a fair bit, like the noise pattern is still pretty small, and maybe you want it even larger. So something that you can do is, it's easier to move in positive values, so let's say like the bigger the number goes, the larger the pattern becomes. So we can use a divide constant, and we'll take a vector, we'll take a constant, and this will be my frequency. So I can just call this, and this will be a vector, and this is 1, 1, and 1, and we'll connect this here, and this goes into frequency. So now effectively what happens we're back to this, but now if I increase the value, it will become larger, so it kind of goes that way. So if I come to about 8, it will go larger still. So it's very easy to get to, larger structures than otherwise. So yeah, as you can see, you get these very nice, peaks and valleys, and you have a lot of these flat places that you can use. The big problem that happens with high and low is that you'll start seeing that your displacement starts to break up. So as you can see here towards the top, your displacement is, completely breaking up. Like if I move this around towards the top, see, there you go. So you have like massive problems here. The thing to remember is that the displacement bound should usually be equal or greater than the displacement amount. Now by default, what we set it up to is equal, and that works for about 90% situations, but with something like high and low, it might not work. So what you can do, which is fairly simple, is just add a number to it. So we can make it say 0.1 and check if it works. Well, almost. So let's make it about 0.2. Yeah, there you go. So now that is fine. So if you start getting problems like these where the displacement is breaking up, just add a number to your displacement bound, and that will kind of take care of it. So now, you'll never have any issues with it. So yeah, and along with this, if I want, maybe I can put like a fit range in there, and we can just sort of lower the source, to just make things a little, sharper. See, so something like this. And if I come up here and let's say I'll make this, maybe I'll make it green or something. So it is quite nice for this kind of work. Now, as a final thing with 3D maps, I would just like to quickly take a look at fit range. Now you have two varieties. You have fit range and you have fit range unclamped. And what's the difference? So if we replace this back with, with this guy, so we're back to using the turbulent noise. Let's set this to say original Perlin. Okay, so that's fine. Now, if we take a fit range unclamped, so if I put a fit range unclamped in the middle, and what this does is if I go negative, you'll see that the noise map didn't change at all, and if we remove the displacement also, like what I'm getting with Perlin is I'm getting like these very large patches of blue and then just a little bit of the noise, because there's a lot of it that's going negative that is not being read by the ramp because it's just reading 0 to 1. So but in displacement, of course, you see it. So if I take this into negative, then you're able to, yeah, there you go. You see, you're able to access it much more better. The difference between this and fit range is fit range will actually clamp the value. So if I was to replace this, see here, even though this is completely flat, but in displacement we get to see that there is some noise pattern there which is going into negative values. But if in the middle, let's say I bypass this and I'll right click here and I'll take a simple fit range, and what you'll get is that all of a sudden those areas become completely flat. So you have no, like if I increase this, see, so so what it does is it just completely flattens out those areas without letting you go into negatives. Like if I push this a little into negative, though some of those values will come back, like they are still there. It's just that you can't see them. So when you want to create areas which are like, absolutely flat, then fit range is quite nice. So giving another example, like if I bypass this and we'll just bring back this, you'll notice that even if I go into negative here, okay, and I start to lower this guy, you'll see like, the peaks kind of remain sharp. Like at no point are they flattening out. But if we do the same thing with the fit range, so if I start to lower this, so after a certain point you're going to start seeing that the tops actually become plateaus. See, like you're starting to see it here right now. So if I start to get closer still, see, so you actually start getting plateaus, and that is the big difference. So whereas with the fit range unclamped, it navigates all the values and it never cuts off anything. with the fit, it actually allows you to, if you want, it actually allows you to sort of flatten out areas. And you can, if you want to create specific effects, like if I was to go into negative, then this is really good for creating, holes in your geometry. So if I, let me just get rid of this temporarily. Yeah, and if I just go negative, then it's a nice way to create dents. Okay, that's a bit much. Yeah, there you go. So if you want to create stuff like that, yeah, so you can create, like, cracks and older material, like walls which are kind of breaking up a bit. So that's the basic of it. That's what, fit range unclamped can do. So that's the basic difference, and that is effectively, the major varieties of, noise maps and cellular maps that you get with Houdini. In the next lesson, we'll do a small example, and we'll take a look at the Worley noise pattern, or the cellular pattern that we had created using unified noise, and we'll just create like a fully finished material with the, with that particular texture. So the next lesson will be like a small project that will, give you a good idea of how you can use all of this and create proper workable materials. Now that we've finished seeing a majority of the various noise maps, as a small side project, let's complete this material. So what I want to do is to add a little bit of self illumination so this can glow, and then maybe let's have these cracks actually give out light. So I'm just going to come in here to my 3D maps, and I'll finish at this level itself. So let's just keep this. Let's get rid of the rainbow. Okay, so what I want to do is, like, if I want to do it with this, it won't be very complicated, but let's build it up with the proper surface material. So we'll get rid of this guy, and let's just give this a name. So let's call this color. We'll duplicate this. So we want one which will be just for the glow, and let's just call this glow. And now, so you'll see that you'll have a second, okay, it decided to reset the whole thing. Yeah, it does that sometimes, but that's fine. We'll set up the colors again. And we'll take a surface material, a surface model, and let's set up the diffuse color first, and we'll connect this to CF. If we intend to use the physically based renderer, then make sure that you connect the F to the F, which is the BSDF. Okay, let's just hit render, see where we are. We'll pretty much lose all of this. Yeah, so let's just quickly set up. So we want this to be like an orange. Yeah, we also have reflections and specular on the whole thing, so let's get rid of that. I don't want it to shine, so we'll come to reflect and turn it off. Yeah, so there you go. So that's the basic. Let's just adjust this a bit. I want a little more. Yeah, that looks fine. That looks good. Yeah, and let's increase the displacement amount a bit. So let's make this about 0.2. Yeah, so the next step that I want to do is to add a self illumination channel to the whole thing, so which is the other guy that we have. So let me just pause this. So I just wanted to glow a bit, so let's just keep this to like an orange, and the rest will be black. I can just do that, and let's bring it in here. Now of course we haven't connected it, so there's no point rendering right now. So if you come in closer, you should have emit color, which is self illumination. So connect the glow to the emit color, and you'll have to turn it on. So if you come to emission, just enable emission, and so there we go. We have a little bit of a glow. Let's adjust it a bit more. Let's add another point here, and I'm going to jump up the value to about 5, so it's much more brighter. Let's make it slightly more whitish. So I have, see, there you go. So you have like these little glowy bits in the middle. Yeah, and I could make this slightly reddish. Yeah, I think that looks nice. Okay, now what I want to do is let's put a sphere on this and have this whole thing emit light. So what I'm going to do is I'm going to get rid of the area light. I'm going to turn that off. So we just have this, and I'm going to also lower the environment intensity. So I just have this. Okay, so let's just put a sphere just to test this. So let's just zoom out, and I'm going to add a sphere. Let's make it small, and have it come on top, and I'll create a simple material. So I'm going to create a mantra surface, which I'll just let's just call it and let's just call this basic or something, and we'll drag it there. So let's hit render. Okay, so right now we're not really getting anything. That's a reflection because the default material will have reflection on it. If we lower the blur value, we should be able to see it. There you go. Okay, let's hit render. Yeah, there you go. Okay, so what we want is for this thing to effectively give out light. Okay, at a very basic level, if I just come into ROPNet, we'll create another mantra node. Let's call this ray trace, and this will be PBR. And I can come into properties. Let's set the renderer to physically based. Let's hit a render, see what we're getting. And if I was to come to shading and increase my diffuse limit to 2, then you should be able to see light. Okay, why nothing is happening is because I never changed here. So change the renderer used from ray trace to PBR, and let's hit render now. So there you go, you can see a little bit of illumination happening there. If I was to adjust my material a bit, then I should be able to see some more of that happening. But this is completely GI dependent, so not what I want. But let's say if you want to actually use this to emit to emit light, so we don't have to depend on global illumination. So what I can do is, let's turn that off, so we are back to basic, and I'll simply create a light, and let's call it geometry light. And if you come to the light options, to area light options, change this from point to geometry, and in area light you need to pick your geometry. So we are going to pick the grid and tell it to transform into object, so it's going to take that exact location. And then in the material, I'm going to pick the 3D maps that I had created. So it's going to use that material to actually give out light. Now the next thing I want to do is I want to make sure that I exclude this from shadows, because it's going to sort of intersect with the light. So we'll add a tab here called light linker. I'll select the geometry light, and I'm going to exclude this from light and from shadows. So that's good. And now if I hit render, it should be more interesting or better, because this is actually going to give out, see, there you go. So if I start to move it, if I take this guy and move it around, then you'll see that it actually, wherever it goes, that lava is actually giving, those cracks are actually giving out light. So it's so you don't need global illumination, which makes things easier. And then it's just a question of increasing your sampling value. So this is a little grainy. The one thing we can do when you're trying to do stuff like this is make sure it doesn't affect speculars, because that tends to give you a lot of fireflies and stuff. So I can click on light contribution and tell it to take reflect and turn it off, and that usually helps out a bit. So your your grain goes down. And then we can just come into the ROPNet and increase the sampling. So I'm going to reduce the noise level to 0.1 to start off with, and if we focus there, see, now my quality is a lot better than what it was before. So if I was to lower the environment light even more, let me just make this like a dark gray or something. See, there you go. So that's much better, or at least it shows you how far the light can be pushed. So there you go. So that's how you can build up like a proper, that's the whole process of building up like a proper material. So yeah, so if you have something that's light emitting, then you can, uh, use a geometry light, and it can actually take the material of the object and use the self illumination channels and all of that to actually give out light. So, and it's fully it's directly connected to it. So if I come into my material and I was to change this, like if let's say I turn this, let's say I'll make this about 2, and you shall see a change happening. And if I make it say green, then so there you go. So it is directly linked into the material itself, which is much better. Yeah, so that's the whole process. I just wanted to go through we will create more materials as we go along, but I just wanted to sort of go through the process of building something like this, and then how you can use all the various features that are available in Mantra for rendering to get a proper result. In this lesson, we'll take a look at some basic texturing techniques like mixing and compositing of textures, and also how to color correct them. So to do that, we'll create a simple example of a checkered floor, or sort of like a mix between a checkered floor and a parquet floor. So something along these lines, a texture like that. That's a little too small, but I think you get the idea. And then through the process of that, we'll take a look at a few of the techniques that I just spoke about. So to start with, we'll take a material shader builder and we'll assign it to the floor. And I'm going to set my renderer to ray trace. Okay, so to begin with, what we need, we don't need these, so let's get rid of that. The idea would be to create a complete material. So first we're going to set up the entire color map, and once that is done, we'll connect it to a material, and then we'll extract like a black and white channel out of that to control the specular intensity and a few other parameters. So to start off with, I'll just take a color map and I'll pick up a basic wood texture that I'd chosen before, and let's set up the UV coordinates. So we'll take UV coordinates. I'm going to take alright, so if we connect this to the surface output, let's hit render to see what we have, and there you go, that's your basic map. So to start off with, I just want a little bit of tiling, so I'm going to make this about 4 by 4, and now I also want it diagonal. So I'm going to take the rotation in the Z or the W and make it 45 degrees. So this is the first thing that's been set up. Now I don't want the surface globals either for now, so let's just get rid of that. Okay, so we have this. Now I want to create another one which is going in negative 45. So let's just duplicate these two guys, and rather than duplicating the original X form and then doing a -45 and connecting, what we can do is we can set this up like a modifier stack. So I can take a UV transform, put it in the middle, and let's connect this and make this 90. So it's taking the 45 and offsetting it by 90 degrees, and so you end up with that. So now you have both your maps, but the nice part of this is that it's still being controlled from a singular location. So this is just for additional rotation, but my primary transformation and scaling is happening from here. Now the next thing is to mix these maps together. So we have used a mix before. Now you get a couple of mix maps. So you have a basic color mix which will allow you to mix two colors, and we can use that. But you also get a simple mix. Now the difference is that the color map only deals, the color mix only deals with colors. The mix map is more arbitrary, so you can kind of change it to use anything. So even if you want to mix two surfaces together, you can change it to BSDF and mix two materials together. So for now we keep it to 3D vector. That will give us the same result. And if we connect 1 and 2 here and put in the blend, so there you go, so we have a crisscross pattern, so it's mixing the two maps together. Now the third thing that we want is a checker map. So let's just take a checker map here. Again, I just I want to duplicate these guys. I don't want this, I just want a checkered. Now the one thing I'm going to do is I'm going to remove the frequency from here altogether, because we just want it to be consistent, coming in from this place. So I can connect the S and T, and this goes into the bias, and if I render now, so there you go. And if we want, again, we can make it additional, like if I make this scaling to 2 by 2, and so now I'm getting additional scaling. Yeah, okay, that goes in reverse, so let's just keep this to 1 by 1. Or if we don't want this, let's do one thing. Let's put another transform matrix, which is simpler. So I can put that in the middle. Now I've been dropping things on the wire and they get connected. If it's not working out, or if it's not happening on your machine, then if you come to settings, then yeah, so you have this option down here which says enable drop on wire. So if that is off, then the dropping doesn't work. So yeah, in case it's not working, you can just turn this on. Okay, so again, like as I said, if I was to make this 2 by 2, so there you go. So it's a little difficult to make out, but yeah, you can make out the tiling here. So that's, so that way we can kind of just, add up the whole thing and use it like a modifier stack. Now the third thing we want is, I just want the texture to be slightly, darker. Now there are a couple of ways to do it. One is I could color correct one of these. So I can put a color correction in the middle, say here, and we can just modify the value a bit. So there you go. And maybe I can also adjust the hue saturation or something. So there's that, that's something that you can do. But what we can also do is, since with Houdini almost any channel can be mapped, then I can, rather than doing it here for the whole map, we can actually do it after the mix, because that's where it becomes a little more interesting. So if I connect it here, and now if I try to lower the value, the whole thing will adjust, right? But what I can do is the same checkered map. If I was to take let's say a fit range and connect it here, and then connect it to value, and then I can define it. I can say, okay, so wherever the tiles are darker, it's 0.7, and then everywhere else maybe it's slightly lesser. But there you go. So that's much more, that's much more easier. So that way, I'm not changing anything here. So if these maps also get changed, or if we add anything else, it's all going to happen, after the mix. Alright, so that's the basic. One additional thing I would like to do here is also add some noise map to this. So also add a little bit of dirt on top of it. So I'm going to take a turbulent noise. Now for the turbulent noise, I would like to have the surface globals. So I can pick up just type globals, so global variables. But the interesting thing here is I just want position. So I can just say output a single variable, and so it will just output position. And so we'll take a rest position in the middle, and let's connect this. Now I can just multiply these together. So if you come to combine, you have your basic stuff. So you have add, and you have divide and subtract and multiply. So you don't have like a layer node, but this is similar to, I guess, what you get with most compositing software. So you'll have like independent or individual compositing nodes that you can sort of chain up together to get a result. So let's put a multiply here, and let's put a fit range in the middle. Sorry, let's do a fit range unclamped. We'll set the turbulent noise to original Perlin, and let's plug it in here, and there we go. Okay, now let's just set this up. So I'm going to get this to about -1, and the target minimum is like intensity. So the higher it goes, the lesser. Like if I take it all the way up, then I don't see anything. So I can just kind of keep it here somewhere, and let's make this about 3 and 3, and a little more 3, 3 and 3. Okay, and a little more roughness. So let's get that high up. Yeah, and then you can lower the attenuation to, kind of just have it in pieces. See, so if I want this, like that. So if you want like a more high contrast noise, then we can do this. And then as I said, you can adjust the target minimum to define how dirty the whole thing should be. Okay, so that's good enough. Like if you want, we can do something fancy. Like if I want, the noise to also affect the saturation. So we can do stuff like that. So I can do Control C, Control V, and let's try to affect saturation. See, so wherever we have the white areas, you're getting some color, and the rest of it just becomes dark. So yeah, the point is you can do more, interesting stuff. Okay, so now that we have this much set up, we can now finally connect a material to this. So just push everything a little back, and I can simply take a surface model, and we'll connect this to F, and let's take the multiply and connect it to diffuse color. Okay, and then I'll stop this and change this to PBR, and let's hit render. Yeah, there we go. That's what we have. Now I had added an HDR, so I had added an additional environment light before, so which just has a simple HDR, which if you make it 0, then you should be able to see the effect. And what I've done is I have turned off diffuse and volume, so it's only affecting reflections. Okay, so let's just come back here. Let's call this wood flooring. Okay, so let's start setting up a few things. I want, let's just turn this off. I want Fresnel. Let's make it about 1.6. The diffuse intensity I want a little higher. Yeah, set this to about 0.9, and let's get the blur down to about let's get it to about 1. So specular angle to 1. Let's hit render and see what we're getting. Okay, now the first thing I want to do is I want to start affecting the specular intensity. So let's just take a simple luminance, and we'll connect it here. And let's just take a look at it. So I'm going to connect it to diffuse color just to see what it looks like. And for now, I'll turn off the reflection layer just so it renders a little faster. Yeah, so that's what we have. Now I can take a fit range to adjust it. Now the source min and source max, they become like contrast. See, so you have a little more contrast here. And the destination minimum, destination maximum is more like what will be the value. So I'm saying that wherever it's black, it won't reflect at all, and wherever it's white, it will reflect at a range of 1. So the nice thing is that you can convert these maps into actual numerical values, which is not something that you can do with max. So if I'm saying that wherever it's black, the reflection value should actually be like 0.5. So I can actually type a 0.5 here. So it's much more better, or much more easier to control it, rather than just putting in a black and white map and then using brightness and contrast to adjust and try and get a result. So yeah, we want let's keep it to 0 and 0.9 for now, and then let's go back to what it was. So let's do diffuse color here, and these guys go into specular intensity. Yeah, forgot to turn this back on, so let's turn that on. Yeah, so we're starting to get our variation in the map. Let me just do a proper render of this. So there you go, that's the final render at this level. Now I made another small change, which is I changed the color map to texture. The difference being, as we had seen earlier, this has filter types. I realized that my texture is looking a little too blurry, so I just wanted to change the filter type to sync sharpening, which would be better. Let me just do another render so we can compare this. So I have stored it. If you click on the camera here, it will store the image, and so I have that. And let me just do another render to see if that makes a difference. There's a slight bit, not a lot. Let's do one more thing. Let's just come into the ROPNet, and we can adjust it from here as well. So if I come to PBR, and you can come to the output and change the Gaussian to sync, and let's hit render. Don't use sync very often because the grain suddenly looks really sharp, but there we go. I think that's a little better. You can try using Catmull ROM as well. Even that's a decent option for sharpening. But yeah, if you're doing still images and if you want to do some print work, then sync is a pretty good filter. It'll really sort of sharpen up, because the default is kept at Gaussian, which is nice, but it's blurry by default. So sync is better. Okay, so as you can see, like we have, I mean, the difference is very visible. It's a tremendous difference between the two. Okay, so let's just go back. Okay, so this is done. As a final thing, what I would like to do is I want the darker tiles to blur a little more and the lighter ones to blur a little less. So I can let's just call this intensity, and let's make a duplicate. So Control C, okay, so Control C, Control V. Let's call this blur, or you can call it roughness if you're coming from V-Ray. As I'd said before, in Houdini the roughness value is called angle, so you can just remember that much. So if you're looking somewhere and where is the blur value, then there's the blur value. I don't know what is technically correct, but I just prefer, like, it blurs the reflection, so it's just simpler to call it blur. Okay, so what we want is that wherever it is dark, so this is my black value and that's my white value. So I'm going to say wherever it's dark, it should be about 2, and then wherever it's white, I want to make it about 0.7. Now you won't get specular angle over here directly, because a lot of it is hidden, because otherwise the list would be too huge. So if you click on more, then you'll get everything else, and you can look for specular angle. So look at it towards the top or towards what is visible, because if you go down, you'll find another specular angle, because you have 2 layers of reflection. So if we just drag this down a bit, yeah, so there you go. So you have specular angle 2. So just make sure that you read the right hand column, because that will give you an idea, because they're both called specular angle. So you just say specular angle, and then let's connect it there. Even if you don't connect it, then it will be visible, so you can just connect it here. So let's just do a preview. I'm going to store this as well, and let's hit render. Yeah, let's get this lower still, so we have a fairly distinct difference. Okay, since the wood map is in there, let's try to make this a little bit simpler. So rather than using the wood map, I am going to use the checker map that we have, so it will be easier to control it, because those are just simple black and white values. So I can just take the checker map from here and connect it, and this should be a lot simpler now. Yeah, there you go. So very little blur here, and then more blur over there. Okay, we don't want it that low as well. Let's get it about 0.6 or 0.7. So you have some amount. Like if I take this to about, say, 8, it'll be like, so this will almost become matte finished. So there you go. So those tiles are almost at a matte finish level. So not that much, but just to give you an idea of the extreme ranges. Okay, so let me just do a proper render of this, and so there we go. That's our final result. Like if we look at it before and then after, so you have, like, this is completely uniform as far as blurring is concerned, and then here we have our variation. If I switch on preview, and let's just sort of rotate this a little bit, so that's doing like a complete example. We'll take a look at one more. We'll create something like this, so a marble texture where we have certain like, we won't worry about the cracks and stuff on the side. We'll look at that at a later date. But what we have here effectively are like 2 different marble textures that are mixed, and building something a little more complex rather than just using like a checker map. So we'll take a look at that in the next example. In this example, we'll try to create some sort of a patterned marble flooring. So something along these lines. Now I'm going to modify this a bit, but what you have here are essentially 2 marble textures. So one for the larger tiles and one for the smaller ones. So let's make the basic pattern first, and then we can start mixing the textures together. So I'm going to start with a simple material first of all. So let's take a material shader builder and drop it in. We'll call it, okay, so I can get rid of this, and we're going to bring in, let's bring in the stuff from here. So these three I can just do Control C and Control V. That will make things easier. Let's keep this to 0 and 1 for now. Okay, so I'm going to start with a box, so boxes, and let's connect that. Let's hit render to see what we're getting. Okay, and connect this here. So what we should get is, it's a single box with the border being black. So let's just make it big enough. What I want to do is I want to transform it once more and move it by 0.5, so where it's in the center like that. Okay, then I want to take another one, so let's do Control C Control V for the whole thing. Okay, no movement here, but in this case let's just, what I want to do is make it really small and then rotate it 45 degrees. So it's, now it's like this, but if you make the pivot at 0.5 and 0.5, then it should rotate in the center. Okay, so let's mix these two together. So I'm going to reverse this one. So fit range and make it, 1 and 0, so it's black. And then we can take a multiply to mix them. So that way. Okay. Now let's tile this up a bit. So if you tile it, you'll see a problem coming up, like these things will move completely. I kind of worked it out, and what works is if we do 1.415 in both, I'm pretty sure there is some kind of a maths to calculate the whole thing, but I just sort of roughly scale it up, and at this value it fits in perfectly. So even if I get it to about 10 by 10, it should still work. So that's a much more interesting pattern to work with. So let's keep this to 2 by 2 for now. So it's large enough. Okay, now let's keep this a little bigger. And then I want a smaller one, to get the marble texture in the middle. So again, we can, let's keep these because we'll create a bump map later. So again, just do Control C, Control V, and this will be smaller. And then we take an add. So if we take an add, and we can put this guy in the middle, and we end up with that. So that is essentially what we want. So we have, yeah, and if we want these to be a little sharper, we can lower the blur amount, because this is by default there's a, so there you go. And maybe a little bit thicker. So there you go. So that's the basic, creating the basic texture that we want, or the basic pattern that we want. So now we can try to start, creating stuff. So we want an initial layer. Let's get rid of this temporarily. So we want an initial layer where this will be, say, white in color, and the rest will be a marble texture. So we'll take a mix, and we'll take a texture, and let's just do a Control C, Control V here, because we don't need this one to move as such, and S and T, and let's just pick up a texture here. So I have some textures that I downloaded. If I come up, yeah, there we go. So if I can see them, yeah, so let's say this can be for the center, and this can be for, the bigger tile. So I'll take up this one, and let's put this on top. This goes here, yeah, and this comes in to bias. Okay, yeah, the black is on top and the white is below, so let's just switch it. Yeah, so there we go. Okay, and let's change this to, say, RGB color, so we'll have a color value, and then I can yeah, I think the 0.5 offset is good for this as well. Let's take this here. Yeah, otherwise you'll get to see a seam in the middle. You can minimize them from the first one, so it just it doesn't take up as much space. Okay, so that's the basic. We are at this level. Let's take care of the middle bit. So again, I can take another mix, and let's put in this guy here to see what we're getting. Okay, so we have this, the middle spaces are blank, and then I can take another texture, and yeah, we can bring up the same stuff from here. So 1 and 2, yeah, and let's pick up the darker one. So there you go, so that one. So there we go. Yeah, let's do one thing. Let's duplicate this without the offset, and let's bring it here, because we're seeing a seam in the middle. I don't really want that. Yeah, I think that's good. And then this guy can be white, or at least grayish. Now the thing here is that even if you don't want to use this as some kind of a nodal structure, you can always just take a top view and then do a large render of it, and then use it as a tileable map. So the point here is that this can work as some sort of a complex texture building area. So you can build something like this, come in here, change the textures, and get a completely different result, and then render it as a flat image, and then use it for use it as a simple bitmap for texturing. So you can always do that. Okay, so once you've done this, the rest of it should be relatively simpler, and we can pick up a simple a surface model, and this will be color. So again, diffuse color, and this goes here. Let's connect these to the main ones also, and let's switch this to rate to PBR. Yeah, let's hit render. Yeah, so the rest of it is relatively similar. So let's just take this, and let's increase diffuse intensity. We'll take a luminance of the whole thing this time. Now this time we might have a bit of an issue, because these ones are white. So what we might want to do is take the luminance and then multiply it with this guy. So let's just take a multiply. We'll multiply it with this, and that goes into specular intensity. So Fresnel, let's increase that. Yeah, I just want to lower this. Okay, let's hit render, see what we get. So yeah, no reflections here, because if you don't do the multiplication, you're going to get a tremendous amount of reflection in the middle, because this is pure white, and that's what we don't want. Okay, so the final thing that I would like to do with this is we just want to create a bump map, or in our case we could create a displacement map. So again, let's just pick up the properties thing that we had created. So we'll come to 3D maps, and we have properties. So let's just do Control C, come in here and do Control V, and we'll take a displace along normal. Yeah, that will automatically work, because this is always called displacement. Unless you change the name here, then you might have an issue, but usually since there's only one displacement, it's usually called displacement 1, so it works pretty nicely. Okay, and then we can just pick up the same multiply value from here, and we can plug it into the amount. So we'll do that, and let's just lower the scale, and then we can see what we're getting. Yeah, so there you go. Okay, let's not do that. I think we should take because we want the center bit to come up. So let's take this, and our other box, and then add it. So like the way we had done it in the first time. So we'll put an add here and add it with this guy, and that should be better. Yeah, see, so you have this one coming up. Yeah, so that is perfect. That is exactly what we want. The displacement amount can be adjusted. What you can do is if we want this slightly rounded, we can blur the original box a bit more, because we got that down to about 1.3. So let's say if I make it about 8, then you'll get it to be slightly rounded. See, there you go. So that's a lot more rounded. If I make this say Gaussian, then yeah, so if you don't want it as sharp, then you can just increase the blur value and get a little more rounded. The texture will blend a little bit, but it's not enough that it'll cause any kind of an issue. So there we go. So that's essentially how we can use all the various things to create these kind of complex patterns and textures. I'll just try to let's increase the tiling a bit more. Let's just come to 4 and 4. The nice thing about Houdini is that it handles displacement extremely well. So even if you're doing displacement here, you don't need to worry. It will render it quite fast. Yeah, let me just adjust the displacement amount a bit more. So those are two basic examples of how you can use mix to do a variety of things, and then how you can also use the basic inbuilt textures to start creating some kind of patterns, and then you can use those to mix textures together and create something more complicated. There's a final thing that I want to do before I end this lesson. That's not related to this, but it's just another thing to do with texturing and compositing, and how it can sort of open up a completely different area for you. So the nice thing about Houdini is that it has an inbuilt compositing area, and the other really nice thing is that let's just store this. Okay, so that's my marble flooring, let's just call it. And the final thing I want to do here is, just as a simple example without really going into anything complex, is let's say if I was to create a COP2 network, which will take me into the compositing area, and I'll come to composite view, and if I take a file, I can import anything. So let's just say I import this, which is my wood map. Okay, and let's just zoom out. Let's say I just want to do some color correction on this. Yeah, let's do a HSV on this. Okay, so we have the saturation scale. Let's do a little bit of a hue shift, and then let's say I want to do something weird, like I want to do like an edge detect. So it'll give me this, which is very weird, but fine. So, and then let's say I want to use this as as some kind of a texture. Okay, so I'm going to take a null and we'll call it out, and this is where things become interesting. So let's say if I'll have to set up a material for it, so we'll just take a material and we'll call it comp texture, and the only thing I'm going to do here is, to start off just for something basic, is I'm going to take some UV coordinates and connect it to a color map. That's basically it. Now you can't get it in from here, so I'm going to promote the map that you pick up. So if I come back here and I assign it, so the default that I should get would be the mandrel picture. Let me just change this to ray trace. Yeah, so there you go. So now what I can do is, instead of picking this up from the hard disk, I can tell it to pick it up from compositing. So the way to do it is, you can type OP and colon, and then type in the entire path. So you have obj slash sometimes it shows, yeah, there you go. So cop2 net slash, and we want out, and that's it. So now what will happen is, the only thing is it doesn't update automatically, so you will have to stop the render and restart it. But now it can actually bring in the texture from the compositing area. So now what you have with you is a full-fledged compositing software. So if I want to blur this, so if I take a blur on this, and we'll do it in Y and not do it in X. So let's just say I do this, and so if I come back here and render it, so there you go. So what you have now is, essentially you are connected to a full compositing software within Houdini itself. So if you have a texture, you want to blur it, you want to color correct it, or you want to do anything else with it that you could normally do in Photoshop or in a compositing software, you can do all of that here. You can do chroma keying or whatever you want, and then you can pick it up as a texture and use it in your material. So this was just a small thing I wanted to show before I moved on to doing other areas. But yeah, the idea is to use all of your compositing nodes to actually create textures and then use it in your material in real time. So you don't have to write this out, you don't have to render it, you can just directly use it in your material. So that's it for this lesson, and we'll continue again in the next one. Now that we've seen a majority of the basics of texturing in Houdini, let's look at something that's quite different and a lot more interesting. So something that I don't think I've ever seen any other 3D software do. So what we're going to look at is the ability to distort and modify UV maps and how that can be used to create more interesting textures. So we'll just call this UV distort. To start with, again, I'm just going to take the usual stuff, so let's just pick that up from somewhere. So yeah, I'll just take these three, and I think this will have some tiling on it. Yeah, so let's make this 1 and 1. Okay, and we'll just take a simple color map, and let's plug in these two guys, and let's connect that. So let's open up a renderer and we'll just render this. Okay, let me assign the material. Alright, so let's hit render, and that's what we have, Now what is interesting here is that technically these are, your U and V is essentially like a couple of gradient maps. And what you can do is you can distort them or, modify their range to get completely different results. So effectively, if when I tile up a map, so if let's say I make this 4 and 4, and when we hit render, what we're getting is this. If I was to look at it directly, I will see this, because what's happening is that it is crossing the range. So we're getting 0 to 1 for the first tile, and then it's going 2, 3, 4, 5. But if you want to see the actual 0 to 1 values, you can divide it. So or you can get a modulus of it. So what a modulus will do is that, okay, once you give it a range and you say, once it goes from 0 to 1, then the next values will automatically just repeat. So from 1 to 2 will again become 0 to 1, and 2 to 3 will again become 0 to 1. That's at least the basics of it. So if we plug that in and now check it, then that's effectively what you have. So basically you just have a band of, ramps. So what Houdini provides you with are tools which can generate additional or modified UV maps. So the simplest one you get is if you search for Bricker. Now don't search for bricks, because that's like a sort of a custom built bricks map. Like if you double click on it, then you'll see that this is effectively a digital asset. But if you look for Bricker, then you'll get something, and you'll notice what it does is that you have S and T, and then it gives out a new S and a new T. So it sounds like a news and a newt. Yeah, it's essentially a new S and a new T. If you also look for box tile or tiled boxes, that's effectively the same thing, with just a slight difference. You don't have this guy. So B amount is not available, otherwise it's the exact same thing. So I personally prefer to use Bricker. So if I plug in S and T into Bricker, and then if we plug in these guys, and what you'll end up getting, okay, let's remove the tiling from here altogether. So this should be 1 and 1. And what you've essentially got is bricks. So it takes the incoming UV and then offsets the whole thing to make it look like this. And so that's what you're using to do the UV mapping for your image. So if I adjust this, let's say I want it to be a bit more like tiles, and so I want this to be lesser and this to be more. So basically like let's say like wooden planks alternating wooden planks. And let's make this 0.5. Yeah, so there we go. And we'll do a simple example. We'll just try to make some wood panels. So I'm going to replace this with yeah, I think that's okay. Now the problem here is that the map, it sort of squeezes the entire map like that rectangular panel. So if I look at this a little bit wider, so there you go, you have that. So the first thing that we can do is let's put in like the paneling on top of it, and that's where the B amount comes into play. So if I was to just look at the B amount, what you have is that, which is quite nice. So if I just lower the border width a bit, and then I can put it in as an add. So if I just take an add this and that, and let's plug that in here. So hit render, and there you go. So you have paneling. Now the other thing that we can do is what if we don't want it to squeeze in that much? What if we want the map to be a little bit wider? So we can kind of readjust these guys. So again, if I do a modulus of this and check it, that's what we have. And what I would like to do is just stretch it out a bit. What I can do here is I can take a fit range unclamp. Don't take a fit range, because that just sort of clamps down the whole thing above 1, and your mapping will just be completely destroyed. So take a fit range unclamped, which is fine, and then we can just adjust this guy, and if we plug that in here into the U, yeah, so technically what you should be getting is, if you see closely, then the map sort of expands. So instead of getting the range from 0 to 1, now we're getting from say about 0.5 to 1. So we're only seeing half the map. Yeah, and we can also shift it if we want. So yeah, so you can either do a 0 to 1, or we can like a 0.5 to 1, or we can do a 0.5, and that allows you to sort of adjust it a lot better. So these are really nice things that are available, and it's pretty unique. Like, I don't think I've ever seen, usually you'll get like a ready-made map, but this is pretty interesting. Like, you can modify a lot of things. Now another thing that you get which is pretty nice, is the tiles map in Max. You can randomize colors, and you can randomize values of your texture. So how exactly would you go about doing that? So what you can do is, on a very simple level, you get this thing called ID, and if I was to plug that in, yeah, again you can't see anything. So it's basically, I think every tile is given a number, and what we can do is we can randomize that. So if I just take a random and I plug this into random, and I'll take the output, so what I get is this. And if you want to get a different seed value, just take an add, and then we can take a constant and we can convert it to integer and connect that. And so every time I change the integer value, you'll get a different result. It's actually shifting to the whole thing, but that's fine. I mean, you get a different result, so to speak. So what you can do is, once we've done this much, is I can multiply this. So we'll just put a fit range here, so I can control how much I want, and let's plug that in, and there you go. So what you get is, you can get random colors, or at least like a random variation on the whole thing. So you can create your own custom panels or custom bricks or whatever. Like if I come in here and readjust this and make it like that, so we have bricks, wooden bricks, but bricks. Yeah. So like if I replace this with say some kind of a concrete shader, so let me just come up here, and let's say if I take that, yeah, so there you go. You can do that, and I could probably multiply it with some kind of a color, to just make it red. Yeah, so I can just pick a multiply in the middle, and let me just take a constant again, and we'll set this to color, and let's plug that in and set it to maybe like a red. So that is that's like the basics of it, of having so now we have like textured brick So this is one of the types that you get. Okay, now another one that you get is basically what's called as a hex tile, or if you just do a search for hex, so yeah, tiled hexagons. So let's do one thing. Let's just let's disconnect all of this, and we'll start afresh. Yeah, so I'm just going to take all of this and just move it up somewhere out of the way. Okay, and let's do Control C, Control V. Okay, so what tiled hexagons does is essentially again a similar thing. So if I just take tiled hexagons and we can connect these two guys again. So again, if I take a color map and connect this, what you will effectively get is, now tiles sadly does not have frequency values. I mean, that doesn't work, and if you try to, like, you'll have to lower it so you can get that, but I usually don't like that. So you can just keep this to 1 and 1 and get something from here. So let's make this say 4 and 4. So yeah, so basically what it's doing, it's generating UVs which generate hexagons for you. And let's just try to lower that a bit. Okay, so you have that. Now these it's not just necessary that you have to use these for bitmaps. You can use them for any texture. So if I take, say, a soft dot, and let's get rid of that, and we'll connect it to S and T here and connect to amount, then you get this. Okay, and let's put a ramp in the middle so we can get some kind of a color. And so now what you can do is you can actually like squeeze this stuff together, like a proper pattern out of it. So yeah, so all of these things give you a lot of options, and again you will get the random. If you have an ID, then you can generate random values out of it. Let me just check what that looks like, and then we can try and overlay it. So there you go. You have these kind of random. So if you just want to do tiling which has like these random hexagon tiles, then you can use this, which is quite interesting in of itself. So that is, those are like basic ways of distorting or transforming UV maps. Now just to sort of do a few more examples of this, we can also use something like let's just take a color map again. Yeah, okay, let's keep to this, and let's keep this to 1 and 1. And what I can do is, if I take something like a cellular noise, and again this also has the option, it's called S center and T center, which is which effectively does the same things. Like if I connect the S and T here and plug in the border, you get this. Let's increase the frequency, so we'll make it 5 and 5, or maybe more. Let's try 8 and 8. Let's increase the border width a bit. And now if I go back to my color map, and instead of this UV mapping, let's say I pick up these guys, so S and T, and what you end up getting is it uses, like, if I look at this, that's what it is generating, like a gradient version of the cells. But now, since the map is completely gone, let's say you want a little bit of the map in there, we can also mix things together. So if I take a simple mix, and I'll mix the original UVs with these new ones, and I put in the blended version in there, and similarly I'll just do a Control C, Control V, and again I want and plug in these guys. Yeah, so now what you have is we can sort of adjust it. So that's my original, or that's the blended version, and then that is my original. So I can pick something in the middle. Like if I check this with the default mandrel that we have, yeah, so if I select this and start to modify, see, that's the basic, and then that's a lot more distorted. So if you want to take some texture and turn it into some kind of a stained glass image or a pattern like that, then that's pretty interesting. So again, if we take a multiply here, and then we can just connect the border value there, so you get that. So that's sort of like you have a stained glass version of everything. So these are basics of how you can transform or distort UV maps. As a final thing, again, if we just want to modify uh, the values of this. So wherever in any of the nodes, if you have an ID value, then you can use a random to convert that to random black and white values. So if I just take a random again and let's plug that in, so we'll end up with, let me just hit render. So there you go. And then I can just plug it directly into the same texture here in multiply. Now if we want to do something else, like maybe I would like to, like let's say I would like to modify the color values of this, then we could probably instead of connecting it here, let's say we do connect it here, I'll put a fit range, and we can also connect it through a color correct. So let's just keep that a little bit. Okay, and then I can actually put a color correct in the middle, and we'll take another fit range and plug that into shift. So that should allow me to actually yeah, let's not do that much. Let's take this a little into negative. So let's do let's just say minus 0.1 to 0.1. So yeah, so you can do a whole range of stuff. Like even if I plug this into say saturation, I think that would be more interesting. So this is at full saturation, and then we can kind of control it, and we can also adjust the contrast values here. So yeah, the options and the variations become kind of endless then. So more than just making textures or just connecting bitmaps and stuff, this almost becomes like some kind of a complex texture building software, or a procedural texture building software, like say Darktree or something like that. So it really gives you tremendous amount of options. Now another thing that we can do with this, I'll just build it again, I'll build a new one, is we can also start to distort UV maps. So effectively a similar thing, let's just duplicate this much. So if you're coming from Max and you've used the Burcon maps, so within the Burcon maps you have the option to distort textures. You have a distortion map directly given to you. If you want to do something along those lines, then you have a couple of ways to do it. One of the simplest is we can sort of multiply something here. So let's take global variables, and we'll just output position, and we'll take a turbulent noise. I'm not putting in okay, let's put a rest here, and I can directly just multiply this. So if I put a multiply here and I can plug that in, and you end up with this. Now that's a little too much, but let's just try to give it a 3D noise, and we can lower, or let's try original Perlin, and we can lower the amplitude till, or okay, let's do one thing, let's not do multiply, let's do an add. An add is better. So let's just do an add here, because in multiply if I get the amplitude to 0, then everything just becomes 0. That's not what we want. But yeah, this is better. So if I start to increase this, there you go. So you can very easily distort and modify. So if I take alligator noise and increase this, so if I have something like a wood texture and I want to distort it more, so I can just like if I have this, see, so there you go. So you can kind of turn your basic wood map into something like a marble, which is, that almost looks like a map for Jupiter. So yeah, the options become a lot more interesting then. So if I lower this, so anything like whichever one you prefer, see, okay. And like if you just want minor distortions, then we can just, and this looks like a much better wood map than like if I keep it to 0, then that was pretty straight. This looks much more interesting. So you can effectively distort any kind of a map that you want. So not just these, like this is fine, this is a color map, this is a simple bitmap, but even if we take something else, like if I take checkered, and we'll do a color mix, so let's put that there, and even if we plug it in here, you can get similar results, whichever map you want. Like even if we do boxes, so any of them can be distorted and modified for any kind of a result. So if I take the frequency here and make it say 4 and 4, and we'll just increase that, So there you go. So you have tiles, which are distorted. So this is sort of like the roughness parameter that you end up getting uh, with the tiles map. But here you can plug in anything. So any kind of a map that you want, you can use that. So if you want to use a cellular map, you can use a cellular map. There are, the variations become endless. So just by adding these guys, it becomes a lot more interesting. And similarly, you can also start using other patterns to generate or to use them as UV maps. So like, just to give you a very strange example, is if I connect this back and let's disconnect that. So we're back to basics. And let's say instead of this, let's take something like a soft dot in the middle. And again, we'll just plug in the S and T here. And so this is basically generating like a soft circle like that. So if I decide to use this here in the U, and what you'll end up getting is that, or if we switch it, if I plug it into like, let's keep the S, let's put this into V. So we're getting something, not a lot. We're getting like a slight bit of a circle there. But again, so I think this is better. Or if you plug it into both, you'll just get a. So yeah, if you want to do something like one of those circular brush patterns, this is not a bad way to do it. And if you tile it, like if you increase the frequency, then you end up with something like that. So yeah, you can do a lot of weirder stuff. And then if I connect this back here, then you can distort the whole thing. So those are almost like wood rings if you want to do that. Like if I keep this to 1 and 1, and let's say we plug this into both, what we technically get are wood rings. So yeah, it's essentially just experimentations, but you can get a lot of different types of patterns and results from the whole thing. Now similarly, you also get something extra here called as a stripes, which takes only a single U or a V channel. And so if I connect the amount here to S, and let me disconnect that, and we'll use that for bias. So you just get like one ring. And then if I increase the frequency to say 10, then there you go. So this is another way of doing it. If you just want like lower the blur completely and adjust the width to what you want. And if I set the colors here to whatever, like a brown, so you can generate a lot of variety of stuff here. And this is something that's almost completely unavailable inside of Max. So whereas something like this over here becomes much more easier. So let's say if I just lower that size a bit, and then I can also do, I can increase the randomness, which will move it a bit, and we can also randomize the size of it. So yeah, the options become much more interesting. Now since we've been doing all of this, or one thing that also becomes a little apparent when you start modifying UVs is that since you can use any kind of a pattern as a UV channel, you could also paint something in Photoshop, like a black and white image, and use that as a UV map. So if I come to Photoshop, and let's just say for an example, I'm going to take, like a simple, like let's say a brick, and we'll make a new layer. I'll create a gradient, one going left to right, and then let's, duplicate this. Sorry, let's not duplicate that. Let's make another layer and we'll go top to bottom. So that's my U, this is my V. Yeah, let's take both of them and we'll just, duplicate them. And let's transform and let's keep it like this. So again, let's just, we'll make a couple of them, like staggered bricks. Yeah, and let's try something else. Let's take all the U that we have. Yeah, so that's everything. Let's merge all of it together. And then similarly we have 1, 2, 3, 4, and we can merge these guys together. Sorry. Yeah. Let's also do one more thing. Make sure this is 8-bit. Sorry, this is 32-bit because you could get banding otherwise. And let's just try this one more time. Yeah, we'll duplicate it, like that. And then similarly here, and the background I'll make it black. So we have this, so let's again, we'll merge all of these. So Control E. So let's save this as an OpenEXR. We'll call it V tiles, and let's call this as again OpenEXR U tiles. Okay, so let's come back here, and yeah, I'm going to disconnect all of this again, and let's build a new one. Okay, and we'll take a color map, and let's pick up or okay, let's take this so it's just easier to see. And then along with this, I'm going to duplicate this. So let's plug this in, and we'll pick up the U tiles, and Control C, Control V, and we'll pick up the V tiles. And now what I can do is these are black and white, so we can just take a luminance, and that should work. And these will effectively work as my U and V. So if I connect these guys here, and there you go. So what I can effectively do is, if there is some kind of a pattern that I don't have and I'd like to build it and then have it affect my bitmaps, then actually I can make it in black and white and use them as UV maps. You know, the options suddenly become much more greater than anything else you've done before. Now that we've seen a whole variety of ways, a final couple of things here. One is we can also use the XForm here to start modifying, or distorting textures. So let's again, I'm just going to unplug all of this. Let's just stop that. Okay, and again, I'm just going to do a Control C, Control V. Okay, so let's just take boxes, and let's take a color map. And I don't want that to get tiled, so we'll just sort of duplicate the whole thing, make it 1 and 1, and connect this guy here. So we just have our basic mandrel. And what I would like is for each block to just shift the map a little bit. So what I can do is let's take a bricker, and let's connect these guys here. Let's get rid of boxes, or actually we can keep that, but I don't need it right now. And then I can just take a random and get the IDs out. So let me just check that. Yeah, the tiling here, let it be 1 and 1, because this has tiling internally. So what I want to do is remove the stagger altogether, so they kind of go back to being squares. And let's make this at 0.25 and 0.25. Yeah, so that should give me like a 4 by 4. So this is basic. Now what I can do with this is, let's just push the whole thing back. And again, let's get rid of this for now. So push everything back, and I'm going to use this to modify the transform in the main map that I have. So if I connect this in, and let's say what I want to do is modify both X and Y. So I can take a fit range, let's plug that in, and let's say I just want to affect say U, and we can take a float to vector. So plug it into U, and that goes into transform, and there you go. So for every map, and if you do it for both, then that's what you get. So for every map, for every square, it shifts it randomly by whatever black and white values you get in there. And as I had said before, if you want to randomize it more, I could take an add here and add a constant, and if we change it to integer, so there you go. So if I just connect that, and then I can just modify it and get different results. And then similarly, if I take the the BA amount here, and we could take a multiply, or sorry, let's take an add, this and that. So yeah, any kind of a texture that you have and you want to create something like a fancy panel like this, then you can easily do it with this. So you can do a lot of things. You can connect any kind of a map in here and distort it. So if you don't want to add it into this, you can always modify these guys. So if you want to randomly rotate them, you can do that too. So if let's say I duplicate both of these, what I want to do is just randomize between say 0 and 150, and I could plug that into, and this should be just for Z, or W, and we can plug that into rotation. So there you go. So they rotate. I can make it 0.5, so they rotate around the center. So these are a variety of ways in which you can modify and distort UV maps. and it opens up like a whole new area of how you can do texturing in Houdini. Now, as a final thing, we can also use a little bit of maths to start creating our own textures. So I'll take a very simple example. Let's say you want to create, wavy lines. So we'll just do that. And again, I'll just stop this. So yeah, let's move the whole thing on top again. Okay, so what I'm going to start off with is we can take what's called as oscillations. So this creates uh, like a sine wave, and we'll connect the radians and we'll output the amount, and what you should see would be this. Now if I increase the frequency to say about 15, and then we'll end up with that. Now what's happening is you have values going to 1, and then you've also got values going to -1. So if we decide to set up displacement, then you should be able to see it better. So let's do one thing. Let's just come into marble flooring, and I just want to get this, and also we'll need the output and global variables. So we need displacement, output position, or actually we don't need that. Yeah, this is again displacement, and these are properties, and let's take a displace along normal. Okay, and finally let's take a surface model, and that goes into, yeah, and let's set this to PBR. So for now we have nothing. I'm going to get rid of the reflection, so we just have just that. Yeah, let's take all of this and plug it into the amount. So if I render it, I should get waves. There you go. And let's lower the amount. Now what I would like to do is essentially try and distort the whole thing. So I basically want to take the basic line that we're getting and then turn it into this. So what I'm going to do is this is U, and then in the V we want to push it up down. So again we're going to use the X form. Alright, so we'll take trigonometric functions and we'll set this to sine, and I'm going to take t and connect it to radians. And then what we want to do is we want to use this to affect the u. So let's take we'll take a float to vector, connect this to u, and let's take the frequency to about 10 and plug that into translate. And what that should do is it will push the whole thing in a waveform. Now this is a little too much, so what I can do is I can take a fit range, and then we can kind of just start to lower the value, because it's pushing all the way from 0 to 1 and we don't really want that much. So just start to lower everything. Yeah, there we go. And now if we go back to our displacement, let's remove this. So there you go. So you can create way more interesting stuff. Let's increase the frequency here to say about 35. Now you can start doing a few interesting things. So if let's say over here we would like to maybe clamp the values, so I could probably use a clamp here. So let me just stop this and let's lower the max. So instead of going all the way to 1, we should get something like this. So the tops become flat, and then there's nothing going in negative either because we clamped that to 0. If you make that to -1, then you'll get like flat tops, and then this goes to negative. And similarly if I make this -0.5, so there you go. And so things become a lot more interesting. Similarly, if I want everything that's in negative to come up, so let's keep this to -1 and let's just bypass this. So I can take an absolute. Yeah, so if I take an absolute, so all negative values will become positive, and if we hit render, see, so you end up getting that. And again, if I try to add something here in the middle, like let's say if I take an add here, and again I'll take global variables, set it just to position. So this is again just experimenting with it. So if I take a turbulent noise and add that in, let's set it to original Berlin. Yeah, and if we hit render, then there you go. So you get distorted waves. which is a little too crazy right now. But there you go. So that's a lot more interesting. And similarly with these guys, so let me just remove that temporarily. So even with these guys, if I was to use something like an absolute in the middle and drop that in, then the result will change completely. So you get that. And if I want to reverse it, I can use a negate, which will just, invert the whole thing. So if I was to drop that in the middle, then everything flips in the other direction. And let's just bypass the absolute value here. So yeah, if you want to do sand dunes and stuff like that, I don't think this is the greatest way to do it, but it gives you a decent start off point. And I can increase these. Let's say if I make it 25, then you get more waves. And again, we can just come to the EFIT and lower that, and maybe increase this a bit. And let's say just as a final thing in this, let's say if I want them to kind of slope, like there are dunes here and then they kind of fade out. So we can take a multiply. I'll pick up a new one altogether. So let's just take another UV coordinates, because that one is pretty far away. Yeah, let's just multiply the T over here. So if I render it, this should act. Oh, okay. So it's going in this direction. Fine. Let's multiply it with an S. Yeah, let's just stop that. So there you go. So you have sand dunes which kind of then fade away. So that is the whole lesson on how to create and modify and distort UV maps in Houdini. In this lesson, we'll take a look at something else that is quite unique to Houdini. Like in the last one, we saw that we have the ability to distort UVs and modify them, and also paint our own UVs. So similarly, Houdini allows you to use the for loop to modify textures. Now if you've done a little bit of modeling in Houdini, and if you've used the for each node, then it's effectively the same thing. What you're doing is you are repeating or looping certain functions to get an end result. So if I want a dozen boxes to become to be extruded, and I don't want to do them one by one, then I can put it through a for each, do it for one, and then it'll automatically do it for the rest. So effectively something like that, but you're doing it for textures. So we'll again start off with a material, and let's assign this, and I'll call this for loop. Okay, so to start off, let's take a really simple example. I'll get rid of this, and for now, okay, so let's say what I want to do is create a grid, and then I want to continuously create like smaller grids internally. So let's say like when you have a grid in Max, or even if you have a grid here, so you have the larger lines, and then you have the thinner ones in the middle. So let's say you want to create a grid like this. Now the normal way to do this would be like, let's set up our UVs, and I'll take boxes, and let's set up the tiling here. So let's say this is 4 and 4, and let's make it really thin. So if I look at this result, what I should get is that. Now what I want to do is I want to start filling in stuff in the middle. So let's say if I duplicate this, and so I'll increase the tiling here itself. So I'll make it 2 and 2, and now I can multiply these together. So I can put in an amount here. So I'll get additional thing in the middle. And let's say I want another one, so I can duplicate this further and again put in a multiply. And let's say I make this 4 and 4. So again I have something else in the middle, and then I can continue like that. So this is, I'm sort of just repeating the same thing over and over again, and what I want is that for every iteration it should, the tiling should double. So for something like this, as being a really simple example, for loop is a really wonderful thing to work with. Now how exactly do you work with this? So I'm going to disconnect this, and the way it works is we'll just copy this much, because we will need this. Let's move this out of the way. Okay, so we take a for loop, And this is basic. Now next is where most of the stuff happens. So we need a way to get the result out. So you can just start off with something simple. So mostly you just need constants. So you can take a constant and we'll call it result, and this will go in. And then what all do we want to modify? So what we want to modify effectively is the tiling. So and since it's a single value, like x and y are both the same, I can take a single value. So let's take another constant and I'll call this as tile, and let's connect that. And the default value here will be 2. So now if I jump in, so you have two things that are available to you. You have the result and you have the tile, and it's basically, we'll do the stuff in the middle and then that feeds back into the output. And what the output does is it again feeds it back into the input. So as many number of end value that you keep, that many times it will keep looping in there. So if I say 10, then it will keep repeating that 10 times. So if I just keep it to say 3, then it will repeat it thrice. So let's just press Ctrl V, we should have this back. So at the simplest level, what I want to do is this has to come out, but in order for it, so initially there's nothing, right? And then this happens. So this gets multiplied or added depending on the result that you want with all of this, goes out and again loops back and keeps doing that over and over again. Now the one issue here is, since we need to multiply, the result can't be 0, because if you multiply it with 0 you'll just get black. So just make sure this is 1. When you're doing an add, then we can keep it to 0. If you're doing a multiply, always keep it to 1. Okay, so I can just take this and we can take this result and put it back into result. Okay, and now what do we want to do with the tile? So the tile at the basic level will come in here and here. So my default value is sorry, not offset. Okay, yeah, let's keep this to 1 to begin with. So the first one is like a normal grid, which will be 4 by 4. Okay, so we have S frequency and T frequency, and then what should happen to this? So what we want is that every time it loops through, it should double. So we can take a multiply constant and I can say multiply by 2. So every time it goes out and comes back in, it'll always multiply by 2. So that's basically what we're doing. So the result will always be like, initial result is empty, and then whatever you're doing in here will get added, or it will add into that result and come out. And then so now this result is filled with whatever is here in the first iteration, and then the second and the third, and then whatever values you have here will sort of get, you're setting up a loop for those as well. So if I come here and let's keep this to 1 to begin with, and let's connect that. So if I check the result, yeah, let's hit render. So what we should see initially is just 1, and then every time I increase an iteration, you automatically start getting more and more. So this is a really nice way to be able to make complex textures and this kind of stuff, where otherwise you would need 5, 10, 15 textures just for no particular reason. And there you go. So we can adjust it. So to add something more to this, let's say we also wanted to rotate 30 degrees for every one of these. So again, I can take another constant value and I can say this will be rotation. So again, initial value is 0. Let's plug that in, and we want to rotate the W. So let's just bring this back, and let's take a vector to float, sorry, a float to vector, and this goes into Z. I'm pushing a little back here, but okay. And that goes into rotation. So initially there's nothing, and then we can take an add constant and plug this in and say for every addition rotate by 30 degrees. And one more thing, since we want to rotate from the center, make this 0.5 and 0.5. Yeah, so it will rotate from the center. And again, so this is what we've done, and let's bring that back. So again, if we start with 1 and hit render, so that's the first one, and then minute I do the second, you'll get a rotation, and then we do the third and we'll get another rotation. So it kind of if I do something a little bit that will give me a looped value. Let's say if we do 45, so here, and I can do 45, so that will give me something like that. So it's very easy to start adding like a tremendous amount of detail with just a fairly small network. So this is one example. So that's how that's like a basic idea of how the for loop works. Now let's look at something a little more complex. So let's say what I want to do is I want to do scratches. So I want to do a texture which is essentially like random scratches. So what I can do again is again, let's just take a for loop, and again set up the result, or you can just pick them up from here, so let's just take this at least. So I want this. I also want the position to come in here, so let's take the position. And what I want would also be rotation, so let's take the rotation as well. And what I want to do is just to show you very simply, if I take a turbulent noise and we'll plug that in there, and let's say if I change this to original Perlin, and if I increase this frequency, let's say if I make it 15, we also need a rest in the middle, so take a rest position, and let's make this in Z at 0.2. so there you go, so you have like these stretched lines. And then if let's say we could randomly rotate them and have them overlap, then that would give us some kind of scratches, and then we can just adjust it. So if I take like a fit range, and I could just define how many I want. So that's basically what I want to do, okay? And then loop it over and over till we have something that is useful. So if I duplicate this and we could add it, if I just sort of offsetted it, see, there you go. So this is basically what we want to do, just we want to rotate it as well. So let's get rid of all of that, and we want this much, so let's just do Control X and let's jump in. Okay, so rest position, so that's why we got the position in here. So we have this. We don't need to feed anything back into position, but what we want to do is we want to modify rotation. So let's just add the result together. So my result here should be 0 to start with. So let's take the result and bring that back, and let's plug that in now. So if I plug it in, okay, so this is done. Now what we want is for everyone, we just wanted to, okay, now what we want to do is let's check rotation. So let's come into let's do one thing. Let's take a transform matrix in the middle, just so we can rotate it. So we'll take y-axis and start to rotate it. So there you go, so we can rotate it from there. And so this again, we should take a float to vector and connect rotation to y-axis. Let's stop that and fit that, and then again we do an add and rotation, and we can just take an add constant. So rotation, and we'll say 22 degrees. Okay, so if we hit render and let's just increase it. Now the problem that's happening now is because I used a fit range unclamped, there are negative values. So even in add, your negative value is sort of removing it completely. So just make sure that you clamp it. So if you take a normal fit range, see, there you go. Actually, even if you don't, the reason I took it was just to show you what happens. Even if you don't have the fit range, and if we just adjust it with this, it's perfectly fine. So there you go. So we can define how many scratches we want, okay? And every time you increase it, we should get something unique. Now we might also want to move it a bit, because you see this pattern forming in the center. I could effectively just take another one of this, just do Control C, Control V, and let's plug that into translate. So so we don't need to change anything. If it moves by 30, it's perfectly fine. So for each one, it will just sort of randomly move. So there you go. So this is a nice way to generate these kind of complex textures. So if I increase it, and you can always just come in here and adjust how much you want. So if I increase it a bit more, this is fairly random enough. Yeah, let me just connect the rotation to a few more of these. Yeah, let's do one thing. Let's do an add constant, and let's take 20. Yeah, so that way you can just add more parameters, and so that it gets a little more randomized, nothing else. So you don't see like a repeat pattern happening in there. Okay. And then this you can put through a color mix or whatever, or you can add into a bump map and get scratches out of it. So if I take this whole thing and yeah, let's just take the displacement values again, and let's plug this in, and let's just lower this. Okay, and here I'll just put like let's put a color mix, and we'll feed this into the color mix to the bias, so that goes into diffuse color. And yeah, let's plug that in here. Okay, and let's switch to PBR. Let's see what we have. So if we render this, so you have a nice bunch of scratches on the whole thing. And again, so if I want more, then I can always just come in here and lower this value. So there you go. So you have like a lot of scratches on this now. So it's a great way to make textures like these, which otherwise you would need plugins, or you would be making stuff in Max. And then if we distort this like we saw in the previous class, then you can have sort of like rounded scratches and stuff like that. So if I just let's say if I just plug this back in here temporarily, we'll switch to ray trace. I don't want displacement, so I'm going to make this 0. Let me hit render. So we have this, and then if I come in here to my for loop, and let's say if I just take the basic position value, yeah, let's take an add, and let's take another turbulent noise. This is just to distort this, so let's just do an add there. We'll keep this to 3D noise and sparse convolutions. Let's just see what we have to begin with. So there you go. So that looks pretty fancy. And if I lower the amplitude here, yeah, and let's just lower the frequency, so we have relatively larger values. Yeah, and also let's lower the amount of scratches. So there you go. So they could be threads or something else. And let's say if we bring stuff back, so let's go back to PBR, and let's again just get this back. So yeah, so if you don't want to do like straight scratches, and you want to do stuff like this, and then of course this you can sort of plug it into specular intensity or those kind of things to make sure that the scratches don't shine, or things like that. So if right now I was to plug it into specular intensity, it would be reversed because the scratches are white. So there you go. So you just have scratches shining, which doesn't look bad at all actually. So it's like this is matte finished and there's metal underneath it. So we can do something like that. So that's it. Now as a third example, we'll take a look at something a little more fancy. So let's say if I want to do like repeating boxes which also change color every time you repeat them. So we'll do a little bit of stuff inside the for loop, and then we'll do some of it outside. So let's disconnect all of this because I don't need this anymore. Let's get rid of that as well. Okay, and yeah, let's take all of this, and again we'll just move it somewhere. Yeah, and this as well, we can move it down. I don't need this. Okay, so we're back here, and let's just bring up let's just take this much again. So Control C, Control V. Yeah, let's say what I want to do would be, let's keep this at 1 and 1, and let's put this into amount temporarily. Okay, so we have one box. Let's make it small, and what we want is let's just reverse this. So let's do a fit range and we'll reverse it. So this is, the box is black and the rest is white. So like that. Let's do Control C, Control V, and then this one doubles, so 2 and 2, and we multiply it. So we get that, and so I want to keep repeating that. The other thing I also want to do is, let's say for each repeat, I would also like it to fade a bit. So if I take a fit range in the middle here for the second one, and if I just increase the 0 a bit, so you get a little bit of a fade. And so if I do a third one, let's say if I select all of this and do Control C, Control V, and then this is say 4 and 4, and again I'll just plug that in, see, and so, and this is again like a little more. So for each one it keeps sort of fading it out over time. So what we want is that the tiling should keep getting repeated, and then it should also keep fading out. But I want two results. So I want one result which is completely solid, and I want another result which is like this, and I'll explain the purpose for it in a while. So let's get rid of all of this, don't need that. And so this much goes into my for loop. So I can just take this, do Control X, we'll take a for loop, and Control V. Okay, so let's just keep that there temporarily, and again let's just set up the basic stuff. So I want a rotation, I want my result, so that is definitely there, so which will be at 1, and then I want something for tiling. So let's just do Control C, Control V, and this is tile, and then I also want something to fade it. Okay, also for I want two results. So this is result 1, which will be solid, and then this is result 2. So those are my two results, and then this is my tiling. Okay, and then I want something else which will be for fading it, so which will go into the multiply. So that's my tile, which initially is at 1, and then this is my fade. Okay, so that's fine, that's what we want. So as I said, so the first result would be this and that, and that goes out to result 1, and then keeping just result 1 in mind, what I want is for every one of them it should keep scaling down. So I can take the tile value to S frequency and the T frequency, and what this will do is we'll take a multiply constant, and every time this will multiply by 2, and it will come out here to tile. So this will loop back, and let's just check that much for the beginning. If I render, yeah, so you're immediately sort of getting something like a fractal pattern, so if I just lower this a bit, so this is 1 and that's 2, let's make it a little smaller, the box size, so I want it about 0.4. Okay, so that's 1, that's the first result. The second result, as I said, what I want is to have another multiply, so a multiply here, and we want another fit range, which so this same thing comes to another fit range, and this goes in there, and this is the one that will fade out, so let's keep it here, and result 2 comes in there, and that goes into result 2, and the fade value comes into destination minimum. So start in the beginning it's 0, and then it will start to fade out. So the way I want to do it is we can just take a simple add. Now what I can do so that it always fits is that I can take the end result, so we want it always to fit between 0 and 1. So I can do a 1 divided by the end value here. So 1 divided by 3, it will automatically fit at 0.33, and then if I do whatever, so every time if I do 1 divided by 4, it will be 0.25. So I take a divide and I'll take a constant, that's my first, so this is a value of 1. So 1 divided by the end value, and that will add into my fade. So every time it increases by that much value. And let's put it into fade. So let's check the faded result, and what we should get should be this. So every time I increase it, see, like it never fades out completely, so this keeps becoming darker, and you keep getting a result like this, so which is much more interesting. Okay, so what I want to do with this is I have two results. So I have one result which is completely solid, which is nice, which is like this. Okay, and so this goes into a color mix. So we have like two sets of colors. So yeah, let's just make this a little darker. And what I want to do with the second one is I want to use it to do a hue shift. So every time it loops through, the hue value varies between 0 and 1. So we'll take a color correction, and the second result should go to the shift value, and that will do this. So you get these values that completely change. And yeah, let's just make the box a little smaller. Yeah, so you can get like these really interesting results. And if you're not happy with this, we can add a value in the middle. So we can take an add constant and just sort of move it to get a different result. See, there you go. So that's a little more interesting. So you can do patterns like these, which are really different and really interesting, which otherwise would be kind of impossible to do. So the for loop function is quite interesting in the terms of what kind of stuff you can create. So like if I modify this, and if I say that from the initial value itself, maybe we want the tiling to be say 2, so the pattern kind of changes completely, or we wanted the initial tiling to be 4, or if we increase it here, like the multiplication that's coming up, let's say we make it 4, so you can kind of modify and change patterns very easily. Let's say if I make it 2.5. Or something else that I can do is, instead of doing a multiplication, so let's say if I just do an add, so if I do an add constant instead of a multiply, and we'll bypass the multiplication and we'll say add, so that will again give me a completely different result. Like this is really different to what we had before. Like if I lower that value, see, so you're generating a totally different pattern out of the whole thing. And again, if I if I adjust this, and so this kind of stuff becomes a lot more interesting. And then if I increase this to say about 25, then the pattern complexity just really shoots off the chart. Like if I check this, and let's say I'll make this much more saturated, there we go. So let's get this. So if I zoom in, then we should be able to see how much detail we have on the whole thing. So there you go. And similarly, if I change this texture as a final thing in this itself, if I just come in here, and instead of a box I was to take say rings, so if I take rings and do the same thing, so just S and T here, and the same thing. So we don't really need to change too much, just make the connections. So let me just make the connections, and we'll just replace the amount, so we'll replace the boxes with rings. And if I do a render now, and we'll just adjust the ring size, So yeah, so you can do an endless variation of things, depending on what you like. It's just a question of experimentation then. So this is what you can do with the for loop. And as I said, like just bypassing certain things. So we were using add right now. Again, if we just bypass the add and bring up the multiply, then we end up with this. So the pattern stuff keeps changing based on what you want. Okay, so we have both. We have add and, so that's what you can do with for loop, overall. So you can effectively generate a lot of random patterns, but you can also generate like these fractals, which are basically just you're looping stuff over and over again to generate more, complex structures. So in the next lesson, we'll start using everything that we've learned so far and build a couple of fully procedural textures. So we'll start off with a simple example. We'll create a procedural brick texture, and then we'll take a look at a couple more. In this lesson and the next, we'll take everything that we've learned so far and try to create two specific procedural textures. So for the first one, we'll create a brick texture, so a fully procedural brick shader with all the dents and bumps and displacement and everything. Now there is already an existing brick shader that is inbuilt, but this is just to give you an idea of how far you can push the entire system. So to start with, I'm just going to reduce the my render size. So let me just bring this back to 1. Okay, and let's begin. So we'll take a material. Now what I want to start off with is taking a simple tiled boxes, and we'll connect it to S and T, and yeah, let's keep this to about 0.5, and let's keep this to about 0.25. If we take the bricker, then this automatically has the brick amount, which gives you the horizontal vertical lines. But since we are building this thing from scratch, we'll also take a look at how to do that. So we'll get rid of this. So what I'm going to start off with is I'll take stripes, and we'll use this to create our horizontal and vertical type. So I'll connect the S here. Let's check the amount. Okay, so there we go. And just bring this down about here. So those are the horizontal lines. Let's just adjust this a bit more. So let's make this about 0.1, and we'll make this at about 0. And lower the blur so it's sharper. Okay, and similarly we want the vertical lines, so this goes into vertical, and yeah, we should just get that. Now we want these to be in yeah, we can keep them like these. So just take an add, and we'll add these together, and if we check it, then there you go, that's your. So if you want them in reverse, we can just put a fit in the middle and reverse the whole thing. So if I just come in here and I put a fit range, and then I can just reverse the entire thing. So those are effectively your horizontal vertical lines. You can also do randomness here, so if you want them to be sort of randomly staggered, and if you remove the stagger, then they're pretty much, so you can sort of adjust how much you want. Okay, so this is the basic. Now what I want is, second step would be to create colors for this. So to do colors, we'll take the ID, randomize it, and set and connect it into a color. So we'll take a color mix. This is my brick color. We'll name things this time. So this is okay. We take a random. Now we also want a seed value. So take an add and a constant. So we add the constant with the ID. Keep this to integer. So yeah, so we have a constant and an ID, and that goes into random. And this connects into bias. So if we check this, then we should get that. And the reason for doing this is that if I change this, so you can randomize the whole thing. We can set up our color. We have two basic colors available here, so I can just set this up. You could also add in a fit range if you want, like if you feel like maybe I don't want it that dark. or I want the rest of them to be. Yeah, I think so. You can always, adjust it more, but I think this is decent enough because we can just set up colors and that should be good enough. Okay, so we have this, and then finally we can, let me just check this here. We can take a final color mix, and this will come on, like this is, lines are black, we don't really want that. Let's keep the lines white. Wherever it is black, we'll get the brick color, so that is the top color, and then the secondary color will be the cut lines, or the lines in the middle. So we connect this to the top, this goes to bias. So there you go. And then this can be, whatever, like we can have it, and we can adjust the thickness from here. So if I want it thicker, yeah, so there you go. So that's the basic. Now I want to do one more thing, which is before we start adding a few more details, is I want to distort these lines, so they're very smooth and straight. So the one thing that I would like to do is start distorting them. So let's take the surface globals, and we'll only convert it, we'll have only position. We'll take a rest, and I'll take a turbulent noise, and I can set this up to a 3D noise, and we'll connect it into translate. So you'll end up with this. Now just lower it, we'll increase frequency. Now sometimes you have to go pretty low with the whole thing. So what I like to do is you can take a multiply constant in the middle, and then that becomes like an additional amplitude value. As a final thing, I can take a fit range in there to sort of just adjust, like I want a little bit smooth and then a little bit bumpy. So we can just adjust the source min and source max. I can just keep this, a little bit. Hold on, let's do one thing. Let's not take a fit range. Let's take a normal fit range, and let's just lower this to about 0.5. See, so you have some areas which are straighter, and then some areas which are, and also the destination, I'll lower it to about, yeah, that's a lot better. So you have some areas which are broken, and then some areas which are straight. Okay, now as a final couple of things, let's just get these two guys, and I want to add sort of dents and spots, and then an overall grain on the whole thing, but just in the bricks. So that we can add up here. Okay, so I'll take another turbulent noise, and let's plug this in. Yeah, let's temp. So I can take a multiply and plug that in, and just take a fit range in the middle, so that even if we are going into negatives, it won't cause too many issues. So let's keep it to sparse convolutions, and we'll increase frequency. I can lower attenuation till we get spots like that. We can also adjust fit range now. So if I just want to, yeah, if I just want to have some spots here. Okay, let's also take a fit range here. Sorry, a fit range unclamped. Let's bypass this. We'll hit render, and we can adjust it from there. So, and then the fit range is primarily, yeah, there you go. So now you can control it, as to how much you want. And let's just reverse this. So I can just define, how much I want overall. Yeah, I think that looks decent enough. You don't want it very dark because then it won't look nice. And then similarly, I'm just going to, duplicate this much. So let's call this dents, and this is just grain. So again, yeah, let's just copy this, and again this plugs into multiply. Okay, so we want to keep this relatively gentler. Yeah, let's just remove the second one temporarily, so we can see what we have. Yeah, and let me just increase this. Yeah, so we get like a nice grainy texture on the whole thing. We don't want it that dark, so I can just adjust it. And now if we multiply them both, yeah, so there you go. So you have like these darker spots, which again I can sort of control as to how much I want. Okay, so that's the basic, right? That gives us our texture overall. Okay. Now what we want to do is, like, once we've done about that much, as a final thing, I just want to add a little bit of dirt, overall on top of everything. So let's just take that much, and these two as well, and we'll just multiply it on top of everything. So you can just take a multiply here. Let's just adjust it. So I want this to be pretty low. Let's start at 1, and then we'll see where we want to go with this. So I can just plug it in there, and adjust it. Yeah, and increase the roughness. So it's, yeah, there you go. Okay. And then we can kind of adjust it how much we want. Let's try to keep this on original purlin so it spreads a lot better. Yeah. So that's it. So that gives you your, brick map. Chances of building something like this might be rare, but it's just good to know how far you can push the entire system. So like if I come close enough, you'll see there is, plenty of detail in there. I can also try to adjust this a little more. I can try to increase the roughness, or let's just take that a bit more. Yeah, and we'll keep this to sparse convolutions. Yeah, see, so you have like places where it's kind of, eaten up the whole thing. Okay, so once you've done this much, let's just plug in the whole thing into a surface shader, and then we can just set up the displacement. Yeah, let's just pick a surface model, and what I want to do is I want to turn off reflections. We'll just increase this, and so this comes into diffuse color. We'll change to PBR and hit render. So we should get, yeah, a shaded version of this. Okay, now the idea is to set up the displacement. So firstly we want this, right? And let's put this through a fit range, and we also want properties. So yeah, let's just come in anywhere and wherever we have properties. So Control C, so connect that, and then yeah, let's just close this. Yeah, and then we'll take a displace along normal. Okay, so the add value fits in there. This comes here. We'll also put a multiply constant, or actually we can control it through fit range. So this goes positive, this goes negative, and let's keep this a little low. Let's hit render. So there we go, we have our displacement set up. So yeah, so let's just bring the dents in. So those are my dents, and I just want to copy paste this. So Control C, Control V, and bring that in. Let's move all of this a little further down. I don't need the displacement, so it's just easier to differentiate. This will multiply, with that, and let's just hit render. Yeah, so there you go. You have pock marks on the whole thing. We can just adjust how much we want. So let's keep this to 1. Let's get this higher, so they're not that deep. And lastly, let's say you want some variation in the brick heights. So what we can do is the random value that we had generated to control the color, this guy, let's just duplicate, this much. So we're not, or let's just duplicate that. So Control C, Control V. So they'll both have the same seed value. And again, just we'll put a fit range so we can control the heights and plug that in. So what we should get is, see, these are lesser. If I modify the height, see, so these are lesser and these are more. Let's reverse it out. So I want these to be more and these to be lesser. Yeah, so the darker bricks will go down and the lighter ones will come up. So if I was to, adjust it a bit. So there you go, that's the final result. It looks a little big, but once you get the logic of it, it's not really that complicated. So there you go, that's the final result. The displacement looks pretty nice. It feels like there's sort of like cement sort of peeling off these bricks. If you want better quality, as I had said before, you can just come into the grid itself and increase the shading quality, and that will give you a better result. So if you feel like there are places where the map is breaking up or the geometry is distorting in a way that you don't like, then you can increase the dicing, and that will improve the quality. So this is a brick texture. For the next one, we'll take a look at a marble texture. So in the previous example, we saw how to make bricks. In this one, we'll take a look at how to make marble tiles. So what we'll start off with is trying to achieve something like this. And then if we look at marble tiles, then for each tile it kind of varies. Like if you see here, because naturally the stone, each block is a different stone, so the stone won't match. So what we eventually want is that after we make the first one, then for each tile,
it should automatically vary. So we'll start off by creating a basic marble noise map and then figure out a way to distort the whole thing. So we'll again start off with a material, and we're not going to do displacement with this one, so let's get rid of that. And this again I just wanted as position, so let's just keep that. Okay, so what we want to start off with is we'll take a single unified noise, and so we have our surface globals, and we'll take a rest position. And what we would also like is I want to be able to distort this. So I'm going to take a transform matrix and connect that to position. And I'll take a color mix, and for now we'll just take a fit range unclamped in the middle, and let's connect that to bias. So two colors, I want them to be slightly bluish. The colors you can choose. For now I just want to set up something simple enough. Colors can always be adjusted later. Okay, and let's just plug that in and let's do a render. So what we have is this. Okay, so we want something that will give us like we want to be able to generate these veins as well. So the simplest way to do that, we're going to use sparse convolution, and we'll use fold. And so fold works a little bit like a turbulence map. So there you go, you have veins, and if you lower the exponent value, then they should become a little more prominent. Okay, so along with that we also need to add some fractal to this. So let's change it to standard. So we just end up with something like that. Let's lower that a little bit, and we can also take a gradient warp in the negative. Yeah, so you kind of just distort the whole thing. So let's just bring this down a little. Okay, so that will be the basic place to start off with. Now what I want to do is I want to start distorting this. Here again, let's just increase the contrast a bit. So I'm going to take this a little higher. Yeah, I want to offset the whole thing a bit, and let's lower that. All right. Okay, so again, let's just move this back. Let's keep that there, but we'll also copy paste it. And I want two noise maps. So I want to take one in translate and another one in scale. So I'm going to start off with a turbulent noise, and we'll keep this to alligator noise. So let's just call this alligator noise. And again, just connect position. We'll lower the frequency a little bit, and this will be a 3D noise, and plug this into translate. Okay. And if we render it, then we should see something a little more interesting. I'm going to take the amplitude up to 3, and there you go. So you'll start seeing, like, if I lower the attenuation and if we just lower the frequency a bit, you should be able to see, see the whole thing starts to sort of move it around based on the noise map. See, so you start getting like these pockets in there. This is also very nice if you want to create wood. So this is also very nice for that. But so that's step one. We can adjust the roughness. Like if you lower this, then it's a little more smoother. But we want a little bit of roughness, because if you look at this, then there is a fair bit of, see, so you're starting to get like these kind of pockets that are being generated here. And then similarly, I can copy paste this. This one I wanted to be sparse convolutions. Again, we'll set this to sparse convolution. This one will go into the scale value. So if I plug this into scale, of course I don't want amplitude to be that much, so about 0.8. And if you plug that into scale, then there you go. So that gives you enough of distortions. Yeah, so you get these nice little pockets, and then you can come into unified noise and you can sort of adjust it. So if I start to lower the frequency in Z, so you can change the map quite well. Also, like offset will allow you to modify the whole thing. So depending on, so this is a very nice way to generate granite or marble or any of those things. It's just a nice way to distort everything, and we can lower the exponent to sort of make it darker. So this is something that you can adjust, how much you want, like more or less. Now along with this, we can also adjust the output. So if you come to output, and we'll just do output, and I'll take bias, and we can just adjust that a little bit in positive or in negative to just make it a little more sharper. So this is a decent enough place to start, and then as I said, you can adjust things here if you want a little more contrast. And if you want a little bit stretched, then if we modify these guys, like if I lower the sparse contrast, see, so this stretches out, so if I lower the frequency here in these guys, then you automatically get, the whole thing to get stretched out. So like what's happening here. Yeah, so you get it to be, the colors as I said is something that you can choose. So if you want more contrast, then we can always just adjust that. Okay, now if I want to get the veins to be a little more stronger, then what I can do is I can use a trigonometric function. So I'll just take a trigonometric function and we'll plug the noise into radians. And for now I'll just use this, like I'll just check what this looks like. Yeah. And if I set this up to sine, and I'll take it to about 10, the frequency, and that should give me, these things. So if I keep it at about 7, so it's a nice way to get these stronger patches. So if I take it to about 15, so there you go. So 10 I think is a good enough place to be in. Then what I can do is I can just put this, on top of the whole thing as an add. So if I take an add here after the color mix, and we'll take a fit range, so we can adjust it and plug that in. So you get these, like, you have these stronger patches. Of course that is too bright, so what we can do is I can take the source max and increase it to fade it out a bit. See, so you'll get, patches here. But yeah, just increase source max till it fades out a little, and then you can just lower the destination max to fade it even more. But yeah, this is a nice way to get, sort of like stronger patches on the whole thing. See, so this is nice, but then this gives you, like those nice stronger areas of white or, whatever color that you want. So then it's just a question of increasing roughness. So if I come in here and modify the roughness a bit, like if I just take this a little higher, there you can add, I think let's not add roughness here, let's keep this simpler, of a cleaner area, but we can increase roughness in sparse convolutions. So if I take this higher, yeah, so you can have much more sort of a detailed noise map. Yeah, so this is completely up to you, like how much you want to keep. If you take it too high, then it might not, it might look too noisy, and you might not get the effect that you want. Okay, let's adjust the output as a final thing. So you can modify this any which way you feel like. You can also try other ones. I thought this one looks, sparse convolution works the best, so I kind of worked with that one. But you can kind of pick and choose and decide which one, works for you. Yeah, so let's just keep to sparse convolutions. I think that works. Okay, so now that we've set up this much, the next step is the more interesting one. Let me just take this a little higher so I can fade it out a bit more. Okay, so now what we want is that for every tile, it should automatically vary. Also, if we want, we can add a little more noise on top of the whole thing. So like in the last one, we took a little bit more, we took a much more smaller noise, and you can kind of multiply it. So you'll get a little bit of a grain in there. So let's just take, we'll just copy paste this without any of the other ones. Yeah. And just take a turbulent noise, and we'll increase the frequency to about 20. And yeah, let's just take a fit range, and we'll take a normal fit range as well. And let's put a multiply here. So if you render, then we should have, yeah, a noise on top of the whole thing. Let's just adjust it so it becomes a little more gentler. And then we can just define how much we want. Yeah, so that's better, so that's like adding a little bit of grain on top of the whole thing. So it's not as smooth. You can just increase roughness. So yeah, like even if you come close, there's a lot of detail in there, so it never really loses the quality. That's one of the nice things of making stuff using, procedural textures, that you can go really close. Even though the process feels a bit longer, But if you make it once and then you save it, you can keep, reusing the whole thing again. Okay, now we come to the final bit, which is we want to vary the stuff for every tile. So I'm going to take UV mapping. Let me just set it up here once and then move on from there. So I'm going to let's take basic, UV coordinates, and I want boxes. And let's increase frequency to 4 by 4. Then I'll take a random. We'll connect the seed and let's feed that in here just to see what we have. So we have this. We'll do the same thing. I'll put a add in the middle. So we'll take an add constant. And so if I change it, then I get different values. Now what I want to do is we want to use this to modify frequency. So for every tile, you'll automatically get a different frequency. Okay. We can also work with offset. Even that will work. So if I come in here, I want to directly jump into offset, like forget the X form in the middle. So even if we don't have these, it would be okay, but we'll remove that a little later. So this will be a float to vector. So all three will be roughly the same. And let's set a basic range. So we want the offset, say, from 0 to 20. The offset value doesn't really matter. So let's take a fit range in the middle, actually. Yeah, so let's just right click there and we'll take a fit range. And let's do 0 to 20. And then this will plug into the offset. And if I render it, we should be able to see an initial change itself. So you can start seeing like a break there. So that's for one of them. And then you keep changing it for everyone. So I can just duplicate this whole thing, so that we have different random values for every one of them. And I can plug this into offset here and I can modify this. Okay, so but more than offset, it's better to work with, so we can get rid of this. This is not needed. Like that's not really doing anything anyway, so it doesn't matter. But more than offset, frequency is what will work better. So let's just remove this. The range, we don't want it that much because we don't want the frequency to be very high. So what we want to do is, let's say, start from 0.2 to about 0.9. And let's plug that in to frequency. And the same thing here. So we are at 0.7. So roughly the same values. So about 0.5 to 1.2. And switch this to frequency. So if we hit render, so for each one, like if I lower this, and we can start to adjust the whole thing. And as a final thing, we'll also add this here. Now, the only problem here is that we can't take a float to vector. This is effectively a vector 4. So we'll just have to change that much. So we'll take a float to vector 4, and we'll use the same values. So we'll take the same fit range and, plug that into all 4 and just plug it into frequency. Yeah, there you go. So that is much more prominent now. So all three of them need to be modified in order to get, a decent result. Or if we want, we can take a brand new one again. So if we just do Control C, Control V, and, so for each one we have an independent, noise value. So then you just adjust your ranges of how much you want. Yeah, and your detail value can increase accordingly. So that's it. That is the overall process. And then as a final thing, yeah, there you go. So that looks fairly decent. And then as a final thing, I can just take, the boxes, the amount from there, and we'll just keep it high. We'll take a fit range and we'll just add like white lines in the middle. So that will give it a much more sort of a finished look. Yeah, let's just see what it looks like. Yeah, reverse it. So there you go. So each tile automatically becomes independent. We can just lower the blur amount here. And so even if I jump this up, so I get it about 10 by 10, and you'll see they will automatically, so each one still looks completely independent. Like some places you have some similarity and then others will be completely, unique. Yeah, there you go. So that adds a little more detail on the whole thing. So yeah, even if we come in close enough, you'll see there's still enough detail for the whole thing to hold up. And then I'm not going through the remaining process, but I'm pretty sure you can figure it out. So then it's just a question of adding a surface model and then extracting a luminance channel out of it, so you can get a working, material out of this. These lessons were mostly built up to give you an idea of how far, Houdini can be pushed when it comes to building materials and textures, especially procedural textures. So this is essentially it. In the next lesson, which will be the final one, we'll just take a quick look at how to build a surface model or something similar from the basic nodes that are given to you. So you have a diffuse node and a reflection node, and how to use the two of those to create a simple enough material. In this lesson, we'll take a look at two relatively smaller topics, but quite important ones. The first one being creating gradients, and the second is how to use point color to modify your materials, or how to bring point color into your materials. Before we do that, I just want to quickly go over one more thing as far as modifying UVs are concerned. So this is fairly simple. It's something that I'd missed when I was doing the UV modification chapter. So I just decided to add it in over here. So what I have is the default image, and let's do one thing. Let's just change that to a wood image. So I'll just do this. Yeah, so we have this, and let's say what we want to do is we had seen an example of doing a parquet floor. So where you have alternating vertical and horizontal wood panels. And what we had done that time was we had created two separate maps and then modified the UV channel. There is another way to do it. So this is the other method of doing it. So what I'm going to do is, instead of doing it that way, we'll take a checkered map and we'll just plug in these guys here. And I'm going to take this to 4 and 4. And what we can do is, so this is effectively going to generate black and white values. And we'll remap those values to control our scaling or rotation. So just to give you a very simple example, let's just come back to the mandrel, and let's say what I want is alternatingly there should be like less tiling and more tiling. So let's say we'll put a fit range, and the black ones should have a tiling of 4 and the white one should have a tiling of 8. And we'll take a float to vector, and this will affect x and y, or u and v, and connect that to scale. And if I render, so based on the checkered values, it will automatically adjust the tiling. So similarly, if we switch back to the wood map and we'll remove this, or let's just modify this and we'll say for rotation it will affect w, and the default should be 0 and otherwise it should be 90. And if we connect that to rotation, then you get this. Or if we do something like 45 and minus 45. So it's very easy to adjust it. Let's add a little more tiling to it. So we'll just say this is 4 and 4. So you have a little more tiling, but there you go. So something like this, again, just as a very simple example of how you can modify UVs using other maps. Okay, so this is something that I just wanted to cover because I had forgotten to cover this particular example in the UV modification chapter. But let's move on to what we actually need to cover in this lesson. So one of the things which I haven't talked about as yet is how to create gradients. And the thing is, again, there is no actual gradient map in Houdini. What you get instead, if I was to temporarily get rid of all of this again, is you have what's called as a ramp parameter. Now you won't see anything here, but once you connect it and if you come up, you'll find a gradient being generated. Now by default it's not going to do anything. If you try to render it, you won't see anything. Now if you are coming from max, then in the gradient ramp you have a whole types
you have a bunch of types of gradients, right? You have linear and radial and all of that. And you also have something called mapped. So what mapped is that if you take any kind of a black and white image and plug it into the ramp, then it will set, a gradient based on those black and white values. So sort of like the gradient map adjustment layer that you get in Photoshop. So same thing. Now imagine this is always in that mode. Okay, so it doesn't generate anything on its own, but you have to feed things into it. To put it very simply, like if I plug in S, then that will give me, a horizontal gradient. If I plug in T, then that will give me a vertical gradient. And anything we add in the middle, so if I take an add here, and I'll take global variables, set this to position, and if I add that in over here, then there you go. So you can modify. So that's like adding noise into your shader. So anything that you want to generate, you have to generate this way. So for example, if I want to do a radial gradient, I could take a soft dot. Let's set this back to 1 and 1, because a soft dot generates a circle. And so if you connect this and plug it in, so there you go, you have a radial gradient. So anything, so basically that's the point. So if I adjust this to say 2 by 2, and then you'll get that. And once we come up here, then you can start setting up your colors. So, and again, if I decide to bypass this and plug in stuff from here, like let's say this is S and that is T, so it should be, yeah, there you go. So you can, let me just bring this back to 1 and 1. So that could be like an island. Okay, I mean, once we set up the proper colors for it. You also have the option to generate a spline ramp. So this is a color ramp, and then if you have like float values that you want to like if you're controlling reflection and you don't really want a color gradient, you'd like a curve, then you can set it to a spline ramp, and then you can have a curve. Like let's say if here in the middle I would like to adjust this some more. Now here's the one thing that you have to remember. This is a parameter, so every parameter has to have a unique name. Like this is called ramp, and then this is also called ramp, so that's why everything here is shut off. So this has to be called something else. So let's call it ramp 2, and then this will come on. Okay, so if I plug this in the middle, let's change this to a spline. And so if I check this, so there you go. So if I make this 0, then your map effectively disappears, or you can adjust it like this now. So I have additional control over whatever it is, or if I make it like that, so yeah, so you can have color gradients, or you can have a spline. You can also expand this more if you want. Like if I bring this up, then there you go, you can have a much bigger one, and this just closes the values. So there you go. So that's what you can do as far as gradient ramps are concerned. So anything that you draw, so any even if you have a black and white image, like if I come in here and let's say the color map, and we'll generate a luminance out of it. Yeah, okay, sorry, I was expecting another map there. Let me just go back to mandrill. There you go. So if we modify these to something darker, so anything that you feed in, it will automatically set the gradient based on those values. So this is as far as ramps are concerned. Now let's move on to something which is a lot more important, which is using point color in your material. Now if I come here, if I come to material palette and you were to create a simple mantra surface or anything, like I have a clay shader here, so in that you have a point color, or if I was to create a mantra surface, then you'll find that with everything you have an option for point color. So wherever you have an option for color, it will usually have an option for point color. Okay, it doesn't have there, but it has for diffuse. Okay, but if we come in here, let's just get rid of these guys. I don't want this at the moment. Let's just keep the ramp here, and everything else I'll just move. Okay, so if I take a surface model, and if you check here, then there is no option for point color. So it's something that has to be brought in separately. It doesn't it doesn't exist in the base model itself.
Okay, so how it works is, let's just come into our geometry and give it some color first of all. So I'm going to take, for a simple thing, let's just take a color node, and I'll take random, and we'll set this to primitive. So you'll have, like random colors spread out everywhere. And then this I want in my material. So I'll just bring in a surface model. We'll just work with a proper material. And let me change this to PBR and render. Okay, so we have this. And let me just adjust it a bit. I'll turn off reflection for now. Okay, so temporarily, let's just switch back to ray trace and keep this to a side. Now there are two ways to get in the values. The first is you have a ready-made node called surface color, and that does it for you. So you have, it's a pretty huge node. It's a digital asset, has a ton of things in there. But you have the option if you connect color and it says use point color. See, so this is where that whole thing comes from. So you have point color, base color. It's the whole ready-made thing available to you. You know what you had in your material. And if I hit render, then there you go. It brings in the point color. If you turn off use point color, it will go back to base color, and it also multiplies with the base color by default. So this is one way, this is like a ready-made way of bringing it in. The other method, which like if you don't want all of that, you just want to bring in the color, is if you know the name of your parameter, which in this case is CD. So capital C, small d. This is important. If you just type in CD both small, it might not work. Yeah, so we can just come in here. You have a couple of ways to do this. You can take a bind that allows you to bring in parameters, or you can also take a parameter, and that will also allow you to bring in attributes. Okay. So right now we can just take bind, and we'll call this CD, and this is 3 floats, so a vector. And if I plug that in, and that will do the same thing. So there you go. And so once you've done that much, then if I plug this into my diffuse color and bring that back and change this to PBR. So there you go. So that way you can bring up, point colors in there. Okay. So any changes that we make here now, like if I come back, let me just stop that. And let's keep this to point. So it will be softer because they blend together. And let's say if I take a paint, or let's keep this to constant, and we'll make it, let's make it black. And then we'll make this big, and now we can also use this to drive a ramp. So because it's basically a black and white value. So if I take a ramp here, and we'll do, we can just do a luminous because this is a color, or you can do a vector to float. Either ways is fine. So we can do this, plug in any one of them, and this goes into my diffuse color. So if I render, then there you go. So you are, those black and white values, and it's taking, whatever gradient you set up here and adapting it to the surface color that you had. Now along with this is bringing in basic color values, but you can bring in anything. So any custom attribute uh, can be brought in to modify your material. So which is very, very interesting, and it also makes things a lot more powerful. So if I keep this to a side, and let's say what I want is, let's just bring back a sphere. Okay, so let's say what we want is, when this thing is positive of x, it should reflect, and when it's negative of x, it shouldn't reflect. So what I'll do is I will create a custom attribute. So we'll create an attribute, and I'll call it reflection. So we'll just call it ref, and I'll say $tx. So translate x is greater than 0. So it's like a yes and no question, right? So everything positive of 0 gives you a value of 1. Everything negative of 0 gives you a value of 0. If we split this and check it, like if I come to a details view, and there you go. So you will have ref, and then if you move down, so there you go. So whatever is positive, you're starting to get 1, and then whatever is negative, you're getting zeros. Okay, so let's so how can we bring this into our material. So let's come in here and we'll switch on reflections. We'll make it Fresnel and increase it a bit. Let me just again, let's just do a render quickly to see what we have. Yeah, let's bring that up, and let's bring the specular angle down to 0.1. Now what I can do is I can take a bind again. This is a float value and it's called ref, and we will plug that into the specular intensity. And now if I hit render, so there you go, it does a 50-50 split. And or if I do a fit range in the middle, I can reverse it, or you can control it like how much you want. So there's still a little bit here and not a lot there. And if I come in here and let's say if we animate it, so before the attribute create, I'll take a transform, and if I move it, so see, as it goes into positive, there is, everything starts to reflect, and as it comes into negative, the reflections go away. So this makes things a lot more interesting, on a shading level, that you can generate attributes here or colors here, and then you can bring them into your material, customize or modify your shader. So those are two main topics. So similarly, like if I come in here, and within this, let's say I set this to primitive, and we'll do the same thing. I'll do a random $pr plus whatever. So that's the plus whatever is like a seed value. Yeah, let's just see if we just render it, we should be able to see some effect. So there you go, you have varying reflection values, because that's what happens. So every primitive gets a different value between 0 and 1, so you automatically get like a varying a varying reflection value for every polygon. So as I said, this is a really nice way to modify and customize materials. So those were the last two things that I wanted to do as far as texturing is concerned. In the next chapter, which will be our final one, what I want to do is to just briefly go through creating a custom material. What we've seen so far is using the surface model, and as I've shown before, this is effectively a digital asset itself. It's a pretty huge digital asset. But there are base nodes available that you can use to build up this particular thing. And sometimes if you want something very simple, then you might want to do that. So in the next lesson, we'll just take a look at how to build a really simple and custom material.
In this lesson, I want to cover one topic, which is the switch node, and I also want to go through a couple of additional examples. So let's start with the switch node. So I have a simple material that I've already built up here, and if I come in, then what you have is just a simple X form, and I have two color maps. One is my default mandrill, and I have another which is a wood map. Now what a switch node allows you to do is pretty much the same thing it does in object level, which is you can switch between nodes or modifiers or stuff like that. So if I just connect, so you have a switch and you have input. So if I just connect input 1 and 2 and I plug in the result, so if I come in here and do a render, and then if I switch it, then it allows you to switch between maps. And you can switch using a variety of things. So if I was to take a ramp, let's just plug in the S value and I'll just test this, or let's keep this to a spline float, and if I plug this into switch, so I have a graph or I have a curve, and let's say I just do this. So I have 0 and then I have 1, and let's keep it to constant, so there's no blending between them. And what should technically happen is essentially that. So wherever it is 0, I'm seeing the mandrill, and then once it switches to 1, I see the wood map. So you can use any kind of a black and white map to switch, But you can also start doing other things. So let's say if we don't use the ramp here, and instead I want to use attributes. So let's say if I come back to my grid, and what I'll do is I'll create two grids. So I'll create one grid here and we'll give it a UV project. I'll just make it small and we'll just initialize this. And let's duplicate this. So we'll take a transform and let's move it to one side and we'll merge it. Now what I'll do is, this is just a very rough example, but if I create attributes, so we'll do an attribute create, I'll call it S, and let's say the value here is 0, and then similarly I'll create an attribute here which is the same one, S, but this is 1. And if I come back to my material and I was to take a bind like I did previously, and I'll pick up S. Yeah, S is a global variable. So yeah, this is this is a nice way to figure out an error. You can't use words or letters which are global variables. So like P is for position, so S is also a global variable. So let's just come back and we'll change this to, let's say, SWI. Okay, so let's come back to material and let's call this SWI, and then we can just plug this into switch. So what you should get is automatically where there was a value of 1, you ended up getting the wood, and wherever there is a value of 0, you got the mandrel. Now the best thing about this is that it's not just for maps, you can switch anything. So you can switch between materials as well. So there's no limitation there. Like if I was to create, let me disconnect that. Let's say if I was to take a surface model and let me connect the F, so you automatically get like a output of BSDF. I'll duplicate this. So again I'll just take F and plug it out, and this will plug here. So yeah, let's just say this is green and this one is blue, just for these purposes. And if we change to PBR and hit render, then it will automatically get two different materials. So you can actually go to that level. So you can build up entire materials and have them switch using a switch node, and you can have attributes driving which areas need to be switched. So this is effectively what the switch node does. Now I want to do I want to do a couple more examples which I kind of felt would be quite interesting to work with. I'll come back to my grid, my basic grid that I had, and when we were creating basic 2D maps, I had spoken of how 2D maps can be distorted or modified using other maps or ramps and stuff like that. And at that point I had mentioned that you can generate attributes and use those to modify. So just as a very simple example, let's say if I come into my grid and I don't need that, so I have a basic color and I've painted. Let's remove the paint, and what I want to do is I'm going to do a create in context, and let's draw a curve. So I'm just going to draw a curve like that. We'll change this to NURBS and I will resample it, so I have a fair bunch of points on it, and then we can take a carve so we can animate it. So yeah, so I just want to cut it from here, and let's give this a color, and let me transfer that here. So I'll keep it to this side. Let's just make it straight, and we'll take an attribute transfer, and I want to transfer from here, and let's just adjust the distance threshold and we'll blend it a bit. Yeah, let me just give this a few more segments so it's a little bit better. Okay, and so we can animate this, coming in like that. Alright, so what I want to do is I have assigned the cellular map to this. Yeah, I haven't. So let me just come in here. And I have a simple material Let me just assign it first. So I'll just assign it. So that's what we have. And what I want to do is, let's say if we come into cells, we'll increase the frequency to, let's say, 30 and 30, and a little more of border width. Okay, or that's a bit too much. Let's do 20 and 20. And I want to remove the jitter altogether. And let's say that what we want is that wherever the color starts to show up, this should start to distort, or the jitter should come up. So we can just I'll take a parameter, or we'll take a bind, and we'll call it CD. Let's just check this, that we can see the color. Yeah, this should be 3 floats. So there you go, you have your color. And I just want to extract a float value out of this, so any particular value. Let's put a fit range so we can control it later if you want. So you can take any one of them, or actually no, you can't take anyone because this is red, so we have to take the red channel. So my mistake. But yeah, if you would have painted white, we could have taken any one, but since we have painted red, you should only pick up the first channel. And we'll connect both of these to S jitter and T jitter. So hit render, and there you go. So now if I come back to my grid, and if we adjust this, so if I blend it out a bit more, see, and if I also adjust my car value, see, so as the car moves through it, you can. So similarly, if I come in here and also plug it into, let's say also plug it into the width, then we get that. Okay, that's a bit much. So let's duplicate this and plug that in, and then we can just lower it. So you can also, like, if I put this into displacement, then you can have cracks forming over time. So anyways, this was the example that I was talking about, in that early chapter, where I said that you can use color attributes from the object to do distortion of a map. Alright, coming to the final example. Okay, we have taken a look at the for loop, and I just wanted to use the for loop to create sort of like a random pattern. So let's say if you have like a circle or a hex or something, and you just want to randomly scatter them. So sort of like you get something like texture bombing, where you're just randomly scattering textures. So we'll do a simple example of that using hexes. So if I come in here, okay, so I've already set up a little bit. If I do a render, I should be able to see a single hex in there. I've modified it a bit. Let me just keep the size a little bigger. Okay, so just to go through this quickly, so what I have is a for loop. I have my usual result. I want to modify the U and V translation, so the U and V offset. And since we are going to randomize it, we also want a seed value. So this is my seed value. And if I come in, then all I have is I have UV coordinates, I have rounded hexes, I've modified the size to about 0.15, and that's going out the result. So first thing, we'll take an add, and we'll add our existing result, the empty value that's coming in. So that's step 1. Now the second thing we want to do is we want to take the U, and that goes to the S offset, and then we can take a V offset. Now this much is done. Now what we want to do is that every time it loops back, this value should get randomized. So it shouldn't be the same value coming in. So what we'll do is, this is our seed. So the seed should keep changing. Okay. So let's set up the seed first. So I want to take an add constant and give it some random value. This goes into a random. Make sure you turn off this clamp position to integer, because if you don't turn that off, it's not going to work. And that goes back to the seed. So this is for everyone getting randomized. Okay, then let's duplicate this, and we'll take a simple add. So the U adds to the seed, that gets randomized, comes out here. And then for the v, since we don't want the exact same value, we'll copy paste this. We'll just take an additional constant with some random number and add that in. So this will get one value, and then this will get a value with an additional 0.59, and that will also get randomized, and that goes out to v. And that's effectively it. So if I start to render this, so that's my first level, and then every time I duplicate it, I'll get it at a different location. So if I come up to say 30, of course they are going to overlap, so you don't really have a choice in that, but if I make it small enough, and let's make this about 400, and there you go. So you can very easily do these kind of random spots all over the place. Okay, so since these are solid, the simplest thing that I can do here is we could probably put a fit range in the middle, and let me just fade it out a bit. So if we just get the fit value down, there you go. So I can just I can have them overlapping like that, and then let's increase the hexness a bit. But that's the general idea. So you can if you want to start creating like these kind of random values or random patterns, and then if I modify the seed here, you'll automatically get different values. So you don't even have to go into the network, you can just randomize it from there. So those are the 3 additional topics that I wanted to cover before we come to our final chapter of creating custom materials. As I had mentioned before, in this final chapter, we will take a look at how to build a custom shader. So I'll create another material, shader builder, and I'm going to assign it to both, that sphere and this. Let me just check it in smooth shaded. Let's zoom in a bit. Okay. Alright, let's get rid of displacement. Don't need that. Let's get rid of this as well. We won't be doing any mapping in this. So if you type physical, then you have a bunch of things available. You have stuff for hair, you have lighting and phase function, you have subsurface scattering, and you have specular. We'll take a look at 3 of these. We'll take a look at diffuse, specular, and subsurface scattering. And for refraction, you get something else called as refracted light. So that is the one that will generate refraction. So we are going to make a basic material that will do diffuse, 2 layers of reflection. We can generate glass with it, and finally adding subsurface scattering to it. So it'll just give you an idea of how flexible the entire system is. So what we start off with is a physically based diffuse, which on its own just has the basic diffuse and some roughness. If I connect it and hit render, I should get a simple gray shader. Yeah. Okay, so the first few things we need to do is we always want to move it through a conserve energy node, which will make sure that it's physically correct so that it doesn't reflect more light than is coming in. Now with the diffuse, we want a couple of things. So firstly, we want to be able to control the diffuse intensity, and then we want color in there. So all of that, so effectively color multiplied with shading gives you a material, right? So if we take a multiply, let this one be the first, so the output will automatically become a BSDF. And then to start with, I can take a simple constant, or if you're setting it up for final thing, we can take a parameter, and this will be my intensity or my diffuse intensity. So let's plug that in. So if you hit render, everything will be black. And so as I increase this, so there you go. So that's your diffuse intensity. And then we want a color. So again, take a constant and we'll set this to color and whatever. So we can just set up. Yeah. So you can set up anything you want. Like if I pick up a ramp, then we can set up a ramp here. Like if let's say I want a fall off, so I can take a fall off. So you get something called as an edge fall off, and once again we'll take a luminance out of it and we'll take a ramp. So we can get rid of this and instead we'll connect a ramp to this. Get the edge fall off down to 1, and then we can just, if you render it, it'll look like that. So just reverse it out. So we'll get this to be a light shade, something here, and then this can be darker. You can set up a simple fall off value in there. So that's setting up the basic diffuse. Now what we want is the reflection. So again, you have a physically based specular, which is your reflection, and what we want to do here is so you have your basic specular models here. You have Phong, Blinn, and Cone. You have the highlight angle. This is the blur amount. We'll get it down to 0.1. The component label is essentially important for when you want to output channels or when you want to output passes. So like if you come to your PBR and or the mantra node, and you'll see in output it's looking for stuff. So diffuse, reflect, coat, refract. And if you give custom names, then you can add custom names here. And so here when you're building stuff up, so in diffuse you have the option to give it a name. So we can call it diffuse. And so when it renders, it will know what this is. So we can call this specular. Okay, so again we'll take a multiply, and here now I want to give it, let's just connect this directly. So I'll just have reflection. If I render it, I'll just have almost like a mirror. So what I want to do is I want to give it like Fresnel based reflections. So I'll take a Fresnel, and by default this goes from 0.1 to 0.8. If you multiply the KR with the base value, and if you render it, but what we would like is to have values that you can understand. So by default, like 1 doesn't give you any reflection, but here it's sort of the same thing, but here we have to go into decimal places. So what I want to do is we can just take a simple divide, and we'll do 1 divided by our particular value. So this will be 1, and then this becomes our reflection amount. Let's just say reflection amount. So let's say if I make this about 1.5, so this value is what will then give me my reflection amount. See, so as I increase this, so if I make it 1.6, 1.7, 2.3, so now you start getting something that behaves like the default material that you get. So if I get this down to 1, then then there's no reflection. Along with this, if you want an extra parameter to control overall intensity, then we can also have that. So I can come in here, I can take another constant which will be the default intensity beyond the basic Fresnel. And so now we can we switch on the Fresnel, but then I don't want reflection, so I can make this 0. And these two we will add. So your diffuse gets added with your reflection. So if I just plug in an add over here, and they both go in, and that will give me my base shader. So since everything is this open, so if we want to add 2, 3 or even 5 layers of reflection, then it's just a question of adding more stuff into this. So we have all of this, and we can duplicate these two, and this, and we just do Control C, Control V. So the Fresnel remains the same, but this gives me I can control the reflection amount separately, and then we can add this in as well. Or this is a little more blurry than that. Let's make it about 8. So there you go. Now you have 2 layers of reflection, and we can control both of these. So let's bring this to about 0.6, and let's bring this to about 0.6. So there you go. So that's how we can create like a layered reflection. So we can have as many, so because the whole system gets that flexible, you can just do what you want. Okay, now as the 2 final things that we want to do is let's say we want to generate glass. So for glass, I'm going to change the material for the grid. I'll take it back to let me just take it back to clay shader, so that I just want glass on this. Let me just switch back to preview. There we go. So to do glass is slightly different. Make sure your Fresnel is there because we're going to need that. Let's get rid of our second layer that we had created. I don't want that at the moment. And what you get is what's called as a refracted light. and it needs the Fresnel. So if you come close over here and if you keep your mouse, you'll see it's called transmission, and that should go into the normalized, refraction direction. So this comes in here. We don't want any diffuse because that will look weird. So get rid of the diffuse altogether. And again here we can multiply it with a color. So let's just take a multiply. Again, in reflection we haven't added color, but you can add a color, the same way that we had added in diffuse, we can do the same thing here. So we'll just take a constant, and this will be my let's call it glass color, and we'll set this to color. Let's make it again, we'll make it slightly bluish, and this again adds into our main object. So this is my refraction amount now. So this 1.5 is what is the refraction index over here. Okay, so let's hit a render, see what we get. So there you go. So there's our basic glass. So again, if you look at the overall node structure here, this really isn't very complicated. You do have a ready-made shader, so you can always use that. The purpose here is to just show you how simple it is to build custom shaders, and also to show you how flexible the entire system is. Okay, so that's glass, and let's just unplug that. We'll take a new one. So let's keep this to the side. Okay, so let's bring back diffuse, and as a final thing we are going to add subsurface scattering, and that is a little different because it doesn't work directly. Like we can't like if you take physically based SSS, and there is no BSDF output. So the way it works is that you have to create a custom output for it for emission. So what you do is, the way I had worked it out was, you can take a multiply constant to kind of adjust intensity. So if you want the subsurface scattering to be more brighter than what it is right now, you can push it, and then take a parameter. This will be a vector, and in export you say when input connected, and make sure that the export context is set to surface, otherwise it's not going to work. And then we connect this, and this will be called capital C and small e, which is basically emission. So we'll just call it emission. So let's just do a with and without. Let me disconnect that, or let me just cut that out temporarily just to show you what we'll get. So we'll do a control X. Let's do a basic render, see where we are. Yeah, so that's where we are. And then let's just bring this back. So even if it doesn't have to be connected, that's the thing. It just needs to be there. And if I hit render, you'll immediately start seeing subsurface scattering. So I'll just hide the grid so we can just work on this, so it will be simpler. Yeah, so let's come in here again. Yeah, so the way it works is, let me just get a little closer to this. The diffuse color is your subsurface scattering color, so let's set that to something, and increase the attenuation density, so it'll push it higher, so you'll get it over there, and also adjust the scattering phase. Okay, we have multiple scattering on as well right now, so you can turn that off, and there you go, and just get it a little bit towards positive. See, so you have more in the thinner areas and less here. So you have single scattering, you have multiple scattering. If you're doing GI as well, make sure you turn on optimize secondary bounces. It will be faster, and samples will give you more quality. So let's make it 3. And as I said, like if I take this and I make it about 1.5, it won't be realistic, but if you just want to shoot it up higher, so there you go, you have more. You generally don't need to modify this, it's perfectly fine where it is. So that is single scattering. We can also turn on multiple scattering, which will slow things down a bit. But if you're doing multiple scattering, if you change the mode to local BRDF, that tends to work quite fast. It gives you relatively the same effect, but you'll see a tremendous amount of speed difference. Like if I close this, let's open up a scheduler. We'll just clear everything, and let's do a render with normal ray trace. Alright, so here are your 2 renders. This is at fully ray traced, and the second one is at local BRDF. Now of course the fully ray traced is brighter, the local BRDF is not as bright. but the difference is tremendous. Like this is very clean or fairly cleaner, and that's 22 seconds, and the fully ray traced model is about 34 seconds. So you can kind of pick and choose, have a little bit difference in the whole thing, but it'll render a lot faster. So the local BRDF isn't as accurate, but as far as time difference goes, it is the fastest option that you'll get. Okay, so once you've done this much, let's just bring back, let's put in another add, and we can bring back the reflection. And so this will give me the final material that we have. So there you go. So that's our final material with subsurface scattering, diffuse, reflection. We have options for refraction as well, which we haven't added in right now. But as I said, the point of this lesson is just to understand how flexible the entire Houdini material building system is. And you have these minute granular level nodes that you can use to build really custom shaders. So this is the end of the lesson, and this is the end of the entire series as well. As I said in the beginning, the primary purpose was to take a look at how to build textures in Houdini, starting with the basic bitmaps and then going through the entire, all the various patterns and textures that are available internally. Try and connect them to Max so that it's easier for you to make a transition from Max to Houdini if that is the software you're coming from. And then finally moving into what is unique to Houdini, and how you can build and modify and customize textures to a phenomenal degree. And then finally seeing something like this of how you can build a completely custom shader of your own. So again, if you have any issues with this entire video series, or if you have any other questions regarding Houdini, you're free to write me an email. I hope all of this was useful and it will add to your knowledge of Houdini, and help you build better textures or better materials in Houdini.